Okay, hello everyone. Welcome to week 6, day 2. And the focus of today is just going to be window functions. But there's something I've promised to address, and I'm going to use today's session to address that uh, concept. So I think it's good I go back to the very first segments of the training. So I want to address the logical processing order of the select statement. This is going to take me all the way back to, let's see, week 2. This lecture notes. This is a very important aspect in interviews. So in SQL, we have the written order and the logical processing order. Right, this thing right here. Right, and you have to understand why we cannot place the column alias on the where clause, on the group by, the having clause. We can only put it on the order by. So this is how you're expected to write the keywords in the select statement. Sweaty feet will give horrible orders. Select from, where, group by, having, and order by. You have to respect this order. You call this a written order. Now, when you execute this order, this is how the database engine will process what you've written. All right, the most important part of what you've written is the table. What tables am I going to connect to in order to, impose a condition, the group by, impose a condition on the grouping, and then you see where the select clause comes in. You have to understand that the select clause is just containing the information of the columns that you want to see in the final analysis. Right, so the system does not address the select clause first. Although you write the select clause first, the system targets the table. You cannot, for you to see columns, there must be a table. So I want to know the table that is hosting that column. The table or tables, if you're doing a join, see? And then see where the where clause comes in, the group by, having. So the only thing you have to remember is that the select clause is processed by the database engine all the way towards the bottom. So these are the two last things that the database engine does on your select statement. These are the key part that it processes first. This one's right here. The table, condition on the rows, grouping, condition on the groups. Before now, we process the columns we want to return. This is towards the end of the analysis. And then we do sorting. So you have to understand that the column alias is generated at this point. This is where your column aliases are built, right here. So if you put an aspect that is built at this point, if you reference it right here, it will not be allowed. If you put it right here, it will not be allowed. Right here, it will not be allowed. So the only part that will allow or recognize your column alias is the order by, because the column alias are built at this point. You can reference them right here, but you cannot go to the top and try to reference something that is created right here. So the confusion is always the way we write it and the way the system processes it. So this is the written order, how you're supposed to write the keywords in the select statement. But then this is what the system will process. This is the order the system will use to process what you've written. Right, so I want to use this as an example. In today's session, I have this, there's a complete SQL statement. I just want you to check that out. We're going to open that. If you go to week 6, day 2, I have this, it starts like equation. Let's open this document, complete SQL statement. I'm just going to go to this side. I'll just go over the requirement. It's a simple requirement, and then we're going to see the written order compared to the logical processing order. So this is day 2, complete select statement. It begins with a question. We want to look at the business metrics across region and market. So we are using the global superstore database, just as a connection right there. We are solving this business requirement. Return the following business metrics for each market and region. So if you explore that table, you're going to see a market column. There is a market. There is a market right here, market column right here, and there's also a region column right here. So those are the two columns we're targeting. But then this is the exploration. So first we do explore all the columns, try to identify the key columns you will need. All right, so we're going to be showing each market and each region, and we'll be tracking down these business matrices right here. You see, so this is the exploration of the qualitative fields, market and region. I do is select this thing on market to see the different markets we have. We have this, and this. This is a US and Canada market. This is Latin America. This is Europe, Middle East, and Africa. You can check this on Google, and this is Asia Pacific countries. Right. So these are the different markets globally. Right. Now, based on those markets, you have the regions that are available. Right. So it is sorted in alphabetical order. Right. So we're going to be seeing a combination, each combination of a market and a region. Now, if we put those two together, this is what we get. So each distinct combination of market and region, this is what we get. So these two will go into a group by. We are tracking these two combinations across all of these 6 business matrices. You see that? So this is the final picture you're going to get. This is the total number of rows you get in that analysis. Right here, 18. If you want to combine each market and each region, these are the possible 18 combinations. Right. And then all these 18 combinations, we're going to now analyze them across these different business matrices. So you see that this is where the aggregation will be performed. Right. For example, the number of distinct orders placed. When an order is placed, an order ID is generated. So you're going to do a count distinct on the order ID so that we count each order just once. When an order is placed, an order ID is generated. If you want to count the number of orders or number of distinct orders, you have to do a count on the order ID. So that's how you're going to achieve this one. Total quantity ordered. Total quantity ordered is going to be a sum function applied to, there is a quantity column right here. So applying sum on quantity, you're going to get this. Maybe as I'm explaining, I should just be pointing out so that you understand. So this is a count on the order ID to give the number of orders placed. So we are showing each market and each region, and we are tracking down these 6 business matrices. Right. So this is the total quantity, which is sum on the quantity column to get the total quantity ordered. What about the third matrix is the average discount. We do have a discount column. So you just simply need to apply the average function on discount. Average function on discount. This is discount right here. Apply the average on that to get the average discount. And this is exactly what we do right here. And that's the alias. Right. Okay, let's go to the next. The next matrix is the total shipping cost. We have a shipping cost column. We just need to apply the sum function on that column to get the total shipping across each combination of the market and the region. So this is it right here. Do the same for sales and for profit. Total sales, total profit. You just apply the sum function on sales, sum function on profit to get these last two. Right. And putting everything together, this is what we have. These 6 columns have been aggregated. These 2 columns are non-aggregated. So we have to put the 2 non-aggregated in the group by. So this is the explanation for the use of the group by. Why do we use the where clause? If you go back to the question, the final result should only show all orders placed in 2014. Orders placed, so we're looking at the order year. So we use the order year, the order date, and we extract just the year and point that to 2014. This is a condition that is not based on the group. Right, there's no aggregate function in this condition. This is a function, it is not an aggregate function. So that's why we are putting this condition in the where clause. So we understand the grouping, because these two columns are non-aggregated, they must feature in the group by. What about this one? Why the condition on the group? We have this: ensure that the average discount for each market and region combination is more than 0. So now this is a condition on the group. Why? Because it involves an aggregate function. We cannot take this condition and put it in the where clause. So I'm just using this as a revision, so to highlight those key points. So whenever you have a condition and the condition has an aggregate function tied to it, put that condition on the haven clause. See that? So now we understand that this condition goes to the haven clause. Why this condition right here went to the where clause? This condition involves no aggregate function. So this condition is applied at the row level. Why this condition is applied at the group level, and the group is what? Combination of market and region. I went to an interview and they asked very simple direct question: where is the condition on the where clause applied? At what level on the table? And it was just easy for me to say at the row level. Right. So sometimes you use the where clause, but you have to understand at what level of the table is the condition on the where clause applied, at the row level. So even before we get to the grouping by market and region, we first of all focus only on the orders that came in 2014 before getting to the grouping stage. See, that's why the where clause features before the grouping stage. So this one goes into all the individual rows. If you go back right here, how many individual rows do we have in this table? Let me just wait for this to load. 51,290. Those are the individual rows. This is what I'm talking about. This all the way to the very last row. It will be 51,000. This is it right here. 51,290. So this is the original data set. No grouping has been done. That's where the where clause is applied. The where clause is applied at the row level right here. Before the grouping is done, we first of all just zoom in only on orders that were placed in 2014. And then next, we get to the aggregation stage where we do this aggregation across the 6 columns. That's when the grouping comes in, the group by is implemented. We have to group by each combination of market and region. You see that? And then now this condition right here carries, we are not looking at the condition on just the discount. We're not saying that discount should be greater than 0. If you want to look at discount greater than 0, that's a where clause condition. It will just assess the individual discounts at the row level and remove the zeros. This is not what we're looking at. We're looking at average discount. And so the presence of that word average means that this condition goes to the haven clause. And as a result, this condition will now be applied at the group levels. At the point where the haven clause is coming in, the grouping has already been done. So this condition is applied at the group level. This condition is applied at the row level. You have to understand this. See that this is very important. If I remove this, let me just deactivate this for now. And I'm going to show you the region and market will pop up with an average discount of maybe 0. This one right here. This is the grouping stage. You see, we are no longer seeing all the 51,000 something rows, no, because the grouping has been done. We are grouping by each combination of market and region. And from our previous exploration of this, we saw that the distinct combination of there's a mistake right here. Distinct combination of order and market. This is what this is supposed to be. Distinct combination of order and market is 18. The distinct and the group by are very similar. Right, they do the same thing. But the group by comes in when you're doing aggregation. And that's why when you're grouping at this, you see those same 18 combination of region and market. These are them together with the 6 business metrics we are tracking. So I've kicked out the condition on the group. So I've deactivated it. Every single 18 of those groups, they are showing up. The 18 combinations of market and region. Our grouping structure is defined by what? Market and region. So there are 18 distinct combinations of market and region. That's why we see the 18 right here, together with the business matrices we are tracking, 6 of them. I really want you to understand this. So we've moved from individual rows to grouped data. You see, this is very important. So at this level, all orders that came in from the APAC market and the Central Asia region, they've all been put together into one group. And these are the summary statistics for that group. This is pulling things together, aggregating. You're not seeing the individual orders. You're seeing an aggregation of them. See, this is very important. And now let's go back to this. Of these 18 groups, how many group had an average discount less than 0? Just one, or equal to 0. So the condition was to throw out that one. So kick out, let's go back to the original question right here. Ensure that the average discount for each market and region combination is more than 0. Right, so you have to understand why this condition is activated at the haven clause level, because that's a condition on the group. Out of the 18 groups, one group had an average discount equal to 0. Our condition says that the average discount at the group level should be greater than 0. So one group has been kicked out. See? So one group was kicked out. Let me deactivate this. So you see the original 18 groups. And you see the group that had is the USA-Canada combination. This is US and Canada. That's the market. And then the specific region is Canada. This one is kicked out. So as a result of activating this condition. So the condition on the having clause is evaluated at the group level, while the condition on the where clause is activated at the row level. This is a simple thing I was supposed to say in that interview, right? But sometimes you read these things, you don't just read them passing, you don't really take your time to understand what's going on, right? And that's where interviewers have become very skilled. They drill you down, to really understand, to see if you understand what you're talking about. So watch out for an interview question like this. What's the difference between the where clause and the having clause? They both carry conditions. Now, the scope or the level of implementation of the condition is different. See? And one obvious thing why you're processing your thought is this concept right here. The where clause is implemented right after the from clause, while the group by is implemented after the where clause. Sorry, the having clause is implemented after the group by. This could be one of the first things you say just to build your logic to answer that question. You can always start by stating where each feature on the select statement, right? And then now you drill in further. The where clause applies a condition at the row level, while the having clause applies a condition at the group level. If you just go to Google, all right, these are things you should be doing as you're rounding up SQL. These kind of questions that usually go together: where versus having. And I just put SQL like so. All right, if you're not in the mood of reading too many things, just go to images, and I want to see that side-by-side comparison. Which one looks good? It's a good number of them. Let's try this one. Yeah, these are important things you can do. So where clause can be used with a select, update, and delete statement. We're going to see this update and delete later on. Yes. All right, this is a valid difference. The having clause you only see in the select statement. The update statement is used to update information in a table. The delete is used to delete data from a table. So you're going to use that also in the where clause. But the having clause is strictly only used in the select statement. This is a very important difference. Yeah, but when we study the update statement and the delete statement, you're going to understand it. We've done the select statement. Yes, but just remember that the where clause is used. If you want to delete data, you want to use the where clause to identify the data to delete. If you want to update data, you want to use the where clause to identify the data to delete. If not, you delete every data in the table, which is something bad, you see. So we're still going to see the where clause in the update and the delete statement. The having clause is only used in the select statement. See that? Where clause doesn't allow the use of aggregate functions except in subqueries. Next week, we're going to study subqueries. Yes. That's why I keep telling you, if you state down a condition and that condition has an aggregate function, you don't have to think twice, just put it in the having clause. Right. This is very important. The where is a pre-filter and used before group by. This is the point I was trying to make. So where does the where clause feature on the select statement? It's before the group by. This is it. Meanwhile, the having clause features after the group by. That's a difference. This is an obvious difference. The where clause features before the group by. The having clause features after the group by. Very valid difference. See? The where clause applies to each and every row. This is very important. At what level is the condition on the where clause applied in the table? It is applied to each and every row. This is very, very important. If we go back to this condition, year of the order date 2014, that condition is applied to each and every row in the original table. There are, let's see this, there are 51,290 rows. The condition carried on the where clause is applied to each and every one of these 51,290 rows. Meanwhile, the condition applied on the having clause comes in understanding that the grouping has already been done. So this is the level. These are the 18 groups on which the condition on the having clause will be applied. 18 groups. This is very important. You have to see this different. Right. It is very important. This point, this one is linked to this one. The condition the where clause is applied before the group by. You see, before we got to the grouping stage, right? How many rows did we have? Right. We're just going back to the original structure. This is 51,290 rows, and we just go in there and extract only the orders that came in 2014. See. Meanwhile, the condition on the group, which is this one, we just simply evaluate this across the 18 groups we have. These are the 18 groups. We are going to show only this is a group, this is a group, this is a group. 18 of them. We want to only show groups where the average discount is greater than 0. So these ones will be preserved, these groups. This one will be dismissed because it fails the condition. This average discount is equal to 0. This one will be returned. So at the end of the day, out of the 18 groups, how many make it? Will make it 17 groups will make it. See, this is a condition on the group. You have to understand, see this and understand it. This is very important. Right. So I'll encourage everyone to do some things like this. When you see those concepts that are similar, always just go to Google, type them, and then you do that analysis. So this is what we have. This is the full statement, complete select statement with the select, the from, the where, the group by, the having, order by. Sweaty feet will give horrible orders. So this is how you're supposed to type them in. This is what we call the written order. So if I go back to this, this is what we call the written order. It goes from select all the way to the order by. You cannot interchange the position. Now, talking about the logical processing order, this is how the system will process your query. Right, remember, each time you highlight a query and you click on execute, this query is submitted to the database engine and it will process it. So how does the database engine process your select statement? It begins with this. After you know your database, you know the schema, what next is a table. It's an engine, it's a machine. Machines process things in a certain algorithm, you see. Right, this has to follow a certain algorithm. The hierarchy has to be respected. After you know the database, you know the schema, the next thing is what a table. You don't go to columns without knowing the table. So it ignores all of these things right you've written right here. Please take note, all of this is ignored. When you submit this for processing, the system ignores all of this and starts processing from this from clause process the where clause, process the group, process the haven. Now it looks at the select, returns the columns you see right here, and then rounds up this process by sorting. And this is a comparison output right here. See that? So the question that always comes in is, why can't we use an alias? Let me just put an arrow right here to indicate where a column alias is generated. You have to know this. This is where, what did I do? This is where your column alias is generated. Right here. This is where your alias is generated. I kept telling you guys you can only use the alias on the order by. Why? Because you build, it is recognized, it is created right here. It's recognized this. Only thing you can use it is this one. So you cannot create something right here and you start using it here. These are processes in front. You can only use it in a process that is done after where it's created. This is very, very important. So now I'm talking about the logical processing order. These things show up in interviews. Let me go back right here and show you what I'm talking about. Here it says average discount. You see that? If I copy the alias for average discount, this is it. Copy. And I put it, let me not go far. Total sales is an alias, is allowed, is approved on the order by. If I take the total sales, which is this, it is allowed right here, is an alias, is created on the select. This is a zone of the select. Total sales is created right here. If I copy this total sales, Control C, and I put it in the haven clause, and I do this, see what happens. The system immediately rejects it. It tells us that this is invalid. If you want to understand why the system is rejecting this column alias at the level of the haven, you have to go to this logical processing order. Where is the column alias total sales generated? It's generated right here on the select. Where are you trying to use it? You're trying to use it right here. It's not possible. So anytime you attempt to use a column alias on any of these processes, it's going to reject it. The only spot where it will allow a column alias is this. Now, once you write the query and you submit it, you follow the written order, your job is done. When you click on submit, you must follow the way the database engine processes it, and that's a logical processing order. So it follows this order right here. And it's very important to know that the column aliases are generated on the select, and this is where the select is processed towards the bottom. All the previous steps will not recognize the alias that is built right here. It will only recognize it in the order by. So if you want to answer this question in an interview, once you tell them the logical processing order, within the logical processing order, select is processed all the way towards the bottom. So the order by will recognize the alias created on the select, because it is the order by is processed after the select in the logical processing order. After the select, the only clause that is processed after the select is the order by. So if you attempt to use an alias in any of this, you're wasting your time. You see, this is very important. I want to stop right here for questions. Let me see if I can pull up LinkedIn. Somebody did a demonstration on this. I don't know if that is understood. So all these aliases, yes, you can use them in the order by. You're fine. All of these aliases, if you want to sort, you can sort on the alias. But don't try using the aliases anywhere on the where, the group by, haven, is not allowed. The only spot where a column alias can be used is the order by. See them? And in the order by, you have two options. For example, this is total sales. You can use the alias, or you can use the logic. That's the sum of sales. But most people avoid doing this. It's not a syntax error. It's still sorts. See, but just know when you're sorting, you can sort by the column alias column aliases are only allowed at the level of the order by. Look at this. This is what this has an alias. This is the logic, but the alias to that column is this. What is that concept? Total. Okay, we did not use that anyway. If I had added this to the query, then I cannot use this logic. I cannot use the alias. See, group by. I cannot group by an alias. For example, if I alias this as MK for market, I cannot take that MK as an alias and replace this. You cannot group by an alias. You see, immediately it gives you an error. So I don't want to drag this explanation. You're only allowed to use an alias in the order by. And the reason for that explanation is you have to reference the logical processing order. In the logical processing order, the order by you have to talk about the logical processing order, and you have to make them understand that in the logical processing order, the order by is the only clause that is logically processed after the select. Why are we targeting the select? Because that's the origin of the column alias. Column aliases are generated at the level of the select clause. These are select clause, and this is where the column aliases are generated. See, all these column aliases, you can now only use them after they are generated. You can only use them in the order by. Right, this is very important. Right. Any question? Any question on this? Let me go to LinkedIn. So I've been pushing that explanation forward, and we've been able to. Oh, remind me to send out this interview question. This is something I saw yesterday on LinkedIn. I just bookmarked it. I'm going to push it out to you guys. So this is what you're going to see today. Right, and this as well. When you're done with the training, we're going to visit all of the challenges and also do them. So beginning next module, this is what you'll be building. Very interesting dashboards. And there's a lot of SQL challenges going on LinkedIn. You see students solving and submitting the suggestions. At the end of the training, we're going to visit that as well and start working on those projects. Okay, right here, SQL execution order. This right here. So this is it. So have you ever pondered the process of executing a SQL query? The image below illustrates the order of execution for SQL queries. The order of execution is what this is all about, the logical processing order. This is the written order, how you're supposed to write down the select statement, keywords in the select statement. But how does the database engine process the information? That's what we refer to as the order of execution. Right, this is very important. So if you look at this statement right here, the order of execution, it begins with the word, the from. And of course, joins are attached to the from clause. If I was to add a join in this, it will go into the from clause. You usually put this table, we do an inner join another table. See, so joins go at this level. So please take, this is very important, this image. The from clause is processed. What next? Two, the where clause. See, if you look at this comparison right here, after the from clause is processed, the second is a where clause. Right. After the where clause, the group by is processed. And then this thing, see where this thing comes in. Then we have now the select. No, this is wrong. Sorry, I missed out the route. I have to follow the numbers. So it's yes, one is the from, two is the where, three is the group by. This is four. Yeah. So we go to the having clause first before we get to the select. All right. And usually the select distinct features at the level of the select. So I want you to see this. I missed out. You have to understand that if I was to add a distinct right here, right, the select, and then distinct is a component in the select. So once you hit the select, the next thing that follows is the distinct, right? So this is it. So having select distinct, and then see where the order by is coming. You see, in SQL we have, in T-SQL we have top. Limit is not allowed. See, we have the top. If you want to limit the number of rows, you put top 5, top 10, and so top comes right there. And then the offset is also available. So this is the full order right here. So remember, the keyword limit is not applicable to T-SQL. PostgreSQL has that. Right, if you want to limit things, you have to put maybe a top 10, top 5, top 15, right, top 1. Right, so this goes at the end. So this is very, very important. Right. So without any further distractions, just limit yourself to this. This one actually went in depth in that. The key thing to remember is this right here. And the only placement is, the only modification is this. The select is towards the bottom. You're already getting ready to render your result. The columns you want to render out, and then the sorting. Right. Have this in mind, the execution order. This is very important. It shows up a lot in interviews. Right. Okay. I think we're going to rest that case. We're going to now go back to the actual material for today, which is the window function. I'm going to close this. If you look at W3 schools, no, W3 schools do not address this window function stuff. I want to see how window functions are classified in this website we've been using. So if I go to the notes, the tutorial itself, basic, intermediate, window functions are at the advanced category. These are the window functions. Now we're going to see the ranking functions, right? Right. So these are the advanced. So window function is an advanced topic in SQL. Okay, let's get started. It's going to be an interesting information we're going to discover today. Please, if I state something that is not clear, just draw my attention so that I can explain it again. So this is the breakdown of the window functions we're going to study. I'll first of all want you to know the meaning of a window in the perspective of SQL, and then we're going to revisit aggregate functions now in a window environment. Then we're going to look at the ranking functions. Maybe on the lab, we're going to look at, I'll focus on these first two, on the value function, value window functions. There are some databases we have to execute. For example, this one. Let's open this database and execute. I think that's the only database we're going to need. Yes, this is the database window function. Let's open and execute. So just go to Management Studio, open the window function database script and just click on the execute button. It's going to run the script and generate the database. I think it looks good. Query executed successfully. Close down the script and you should be able to see a new function added, a new database called window function. Right here, window function, and it has how many tables? It has 2 tables, employees and the others table. So that's the first thing. So open the window functions database and execute the script. Make sure you close the script. We are done with that after execution. And the next thing we're going to target is this material right here, window functions. That's the lecture material, window function. Right, I'm going to open that one. Just click on the shortcut to open the file. Navigate to week 6, day 2, window functions, open as a lecture material. Right here. So window functions, these are functions that operate on a set of rows and return a single aggregated value for each row. Gradually, you're going to be understanding how this differ from the group by it. So the concept of a window is similar to the concept of a group. But then unlike a group where one value is returned for each group, you see, if this was a group by concept, we're going to get one value returned for each group. You see, but in a window environment, one value is returned for each row. So basically, we are all in the same group, but we preserve our identity. Each row will show up in the group. We are not pulling things together to get one value for the group. No, we are keeping each individual row. And that's the concept of a window. So a window is different from a group. And by the time we're done with this concept, you will be able to understand. So when you apply these window functions, they preserve the identity of each row. We are all in a group, but we are working individually within that group. And that's the concept of a window. So the rows retain their separate identities. This is very important. In a grouping structure, there are no individual identities. If I give you a project and you have to do it as a group, you get a group score. You see that? But then if I give you a project and you're supposed to do it in a window environment, you're going to work individually while you're in that window environment. So you're going to get individual scores, even though you're working as a group. Right. So when I start working on examples, you're going to see how it plays out and how it's going to help you in problem solving. The term window describes the set of rows in the database on which the function will operate. So a window is simply a set of rows. Right. And then how do you identify that a window has been built in a query? The use of the over clause. This is what triggers the creation of a window. So whenever you see a SQL query and you see the keyword over, it means that a window function is being used. Right, this is very important. I will come back to this concept. Right. So let's look at the types of window function. We have that in this document right here, the aggregate, the ranking, and the value ones. Right. All those aggregate functions we saw, we're now going to see them in a group, in a window environment. And then we're going to do the ranking ones. Right. For example, rank employees based on salary. We can use either the row number function, the rank, or the dense rank. These are the popular ones. Right. And then we're going to look at the value window functions, which are lack lead. Right. I will talk about that later. Let's get started with this one right here. So I think I'm going to start by showing you what we know as of the moment with the group by, and then move towards a window environment. So let's take an example right here. We have the window function database, and this is the orders table, right? And we are showing the orders sorted by city. So for example, we have Arlington. This is all the orders coming from Arlington. You have this city, Guilford, all the orders coming from that city. And then we have this city, Shalford, all the orders coming from that. So that's basically what a group will look like. Right. Now, if you look at this task right here, total order amount by city. So for each city, how many cities do we see? There's 1, 2, 3, 3 distinct cities. So based on this question, we want to see the total order amount by city. This question can be solved without a window function. Why? Because whoever is giving this question needs 3 rows, 1 row for each city. So this is, you're going to show the city, the distinct city. You do the summation on the amount, order amount, and then this is the count of number of orders. And so there will be 3 rows because we have 3 distinct cities. You see that? I want you to understand that in grouping, you're pulling things together. Let me execute this so that you can understand. If I pull this, this is Arlington, and all this 1, 2, 3 are summed up to get 1 row. You don't see the 3 orders separately. In a window environment, this 3 will be preserved. You will see this 3 in the final outcome. You see this 4 in the final outcome. You see all of these 3 in the final outcome shown to you in the result. That's the power of a window function. But in a grouping environment, we do summary statistics, right? We show you just Arlington as a city, and we sum up this, this, and this to get the total order amount. See, and that's why you have 1 row for Arlington with those 3 orders summed up. You see, and that's a row right there. See, there were 3 orders from Arlington, and this is the summation of the order amount. There were 4 orders that came from the city of Guilford, and this is the summation of the order amount. There were 3, but then the individual rows, you don't see them. You just see the grouping, right? So that's what we've been doing previously. See, we don't see the 3 rows that come from Arlington. We don't see the 3 separate orders. You cannot see them, right? But today I'm going to show you the window functions. You'll be able to see all those information, right? So now let's switch to phase 1. In phase 1, there will be no partition by and no order by. Remember, the over clause is used to define a window function. And then once you define the window function inside, you can partition the window using the partition by, and you can also sort the rows in the window using the order by. But for phase 1, we're going to dismiss all of this. I will introduce you to this thing gradually. So first thing, this is how you build a window. There's no group by. You use the over clause and you put open parenthesis and close. And when you do it like this, it means that we have 1 window. So all the rows that will be returned in this result, they belong to that window, right? And then what do you do in this window? We want to sum up the order amount. So this is what we call an aggregate window function. This is an aggregate function that has been used in a window environment. This right here is an aggregate function that has been used in a non-window environment. This is just our regular group by. You see, there's a difference. I will come back to this result, so you're going to see why we have 3 rows right here for 3 distinct cities. This is the same thing I'm trying to do right here. But you notice we're going to have more information than what we saw in the previous. So I want you to be able to understand what's going on right here. This is an aggregate function, sum, on the order amount, but then it is applied across a window. This is not a group. So always remember the over clause defines the window. So right now we are looking at this, an aggregate function applied in a window environment. And how do you know it's a window environment? The over clause. If you go ahead and execute this, and then we start understanding output. How is this output generated? If you notice, all the 10 rows in that table are showing up. That's something we cannot see in the group by. That's the first difference. If you do a group by, you not see all the 10 individual rows. See, these are 10 individual rows, 3 from Arlington, 4 from Guilford, 3 from Shalford, altogether 10 individual rows. In a grouping, you don't see that. You see the 3 distinct cities. This is very important. Why? Because we're grouping by city. But then see what we get if we use a window function. we are still using that same metric, sum of the order amount. It's the same thing right here, sum of the order amount. But then we are applying this summation over a window and see how the results look like. All these 10 rows constitute one window. Why? Because we did not split the window. If you want to split the window, you're going to see the partition by. The presence of partition by inside here means we are splitting the window. I want to begin gradually, so I'm not doing any partition by and I'm not sorting any of the records in the window. I need somebody to explain to us how these values are generated and why are they the same across the board. Let's begin with the first one. How is this value generated? Take note, it's what? Sum of the order amount. What's the order amount? This is the order amount. So sum all of this order amount from top to bottom. That's the meaning. Since we did not partition the window, it means that all of these 10 rows are part of one window. So once the window has been defined, this function simply just goes into the window and performs its tasks. You're not changing the definition of the sum function, no. We've just simply changed the environment, in this case, the window. So we have one window which covers all the 10 rows. So this sum of the order amount is simply this plus this plus this plus this plus this plus this all the way down, summation of all of this. And then that same value is reported for each row. A group by reports an aggregated value for each group. That's why if you go back to this, you see this aggregated value is reported for each city. Since there are 3 cities, we see 3 reports, 1, 2, 3. This is very important. In a window function, the function returns an aggregated value for each row in the window. That's why you see all the 10 rows are showing up in that window and they are getting a copy of the aggregated value. Imagine this is your salary, and then I can compare your salary to the overall salary or the average salary in the company. That's the power of window functions. You can do side-by-side comparison. You cannot do this in a group by. I show you your salary, and then I show you the average salary in the company. If I just change this to average and this is salary, I can be able to show an employee's individual salary next to what the average salary in the company. Very powerful when it comes to analytics. This is something you cannot see in the group by. Why? Because in the group by, we're grouping. Right? If there are 3 cities, you get 3 distinct rows and one value is reported for each. You don't see the 3 orders that came in for Arlington. You don't see that detail. But in a window function, you see that. So let me go back to this definition. A window function will return an aggregated value for each row in the window. This is very important, for each row. In a group by, you're returning an aggregated value for each group. And so if you're saying group by city, it means that we're grouping by city. There are 3 distinct cities. We're going to get 3 aggregated values on this column. See, this is what sum of the order amount, 3, because there are 3 cities. This is what counting the number of orders. These are the counts right here. This is very important, you see. But then if you go in a window environment, how do you identify a window? There's an over clause being used. This function right here is not a regular aggregate function. It now becomes a window function, an aggregate window function. It is an aggregate function, sum. It is applied across a window. Because of the over clause, it becomes an aggregate window function. The behavior is completely different. So the behavior of this function will depend on how you define the window. Right, over clause without a partition by means that you have one window. All the rows in this table belong to that window. There is no sorting in the window. You see, that's why I begin by phase 1. No partition, no order by, just the window is present. Every row in that data set belongs to that window. And now we are summing across what? Across the entire window, which is what? So this plus this all the way down. And that one value is reported. It is reported for each row in the window. The group by reports each aggregated value across each group. The aggregated value is reported across each group. This difference, you have to understand it. If you are using the group by, the aggregated value, for example, total or count, is reported for each group. That word group is very important. That's why it's a group by. In a window function, the aggregated value is reported for each row in the window, for each row. That's why this result is very detailed, because we are showing you all the 10 rows in that table, and all the 10 rows are part of that window. So the summation is what? All everything right here. And the answer, which is this, is reported for each row in the window. I want to stop right here and make sure we understand this. So if I take this out, then I'm now working the framework of a group by. The system will start complaining, hey, you need to group by, this query is going to fail now. You have to start adding group by, maybe group by the other date, group by the other ID, group by city. You have to put all of those non-aggregated columns in a group by, which is this. See? But if you want to work in a window environment, you don't need a group by. You just have to add that over clause, you see, and the system would translate that into something completely different from the group by. This summation is not changing. You've not changed the definition of the sum function, but then we've actually changed the environment on which that function will operate using the over clause. So it is going into this window. It is summing up all the other amounts, top to bottom, and it is reporting that value for each row in that window. By the time we go to phase 2, you understand when we start partitioning, you see how it's going to impact that. I hope we have each. Let me just stop right here. Questions? Or maybe let's take an
Yeah.
example. Oh yeah, yeah, go ahead.
Can I ask something?
Yeah,
No,
question.
I
Yeah.
was going to ask. So like the overclose, right? Is it kind of like a bypass of the group by, or if you were to define what we use like the overclose is it kind
Yeah,
of a bypass?
the over clause actually defines the window. It's like a group by, but then it does a much more better job than the group by. So the over clause defines the window on which this function will act. But in a group by, you're
Okay.
putting things into distinct groups. You see what we did right here in the city, group by city. If there are 50 cities, you see 50 groups, right? So group by is is really limited, right? And now in a window, it's like a frame. So you zoom into a frame, all these records are part of that frame. We have one frame, all these records are part of the frame. This is a frame, right? It's like looking through the window. The things you see in that window are based on the size of the frame, right? And if we can further adjust the frame by doing a partition by. So just try looking through the window. The things you see while looking at the window or through the window are things that are within the frame of the window, right? And then framing of the window now is done by the partition by. If you don't partition your window, then everything in every row in that table you're dealing with is part of that window. And that's why we have 10 rows in that. See? So we are now zooming through this window. And we're telling the sum function to do what? Target the other column, the other amount, which is this column, and sum up all the values, top to bottom. And then take that value and report it across each row, across every row that is part of the window. So this function only operates based on how your window has been defined. Let me use an example on salary. Students always understand things when we use salary. I don't know why. Salary is always an interesting example to use. So I want you to show, let me just go over this query. We are projecting, let me just show you the original table, how it looks like. It's always good to start with a base query. So you get to take a look at the original table, that's the employees table, execute, and so I'm asking to see the employee ID. I want you to combine first and last name into this column called employee name. So these two will be fused together. We know about the concat function. We do that with the space in between. Excellent. Show me the department ID, show me the salary. Fine. Get me the average salary. And then see what we are doing. We are getting the average salary over the window. And our window constitutes what? 107 employees. We have not partitioned the window. In the second analysis, we are going to partition this window by department. So only employees in the same department will form one window. See, but then we are keeping all the 107 employees as part of the same window. So this average salary will be calculated across all the 107 employees. This is very important. So this definition never changes, but the scope, where is it applied? It will be applied over the entire window, which constitutes 107 rows. This is very important. Did I do any join right here? No. So we are dealing with the employees table. There are 107 rows in the employees table. So the window is defined to incorporate all these 107 rows. All the 107 rows will show up. This is very important. It's different from a group by. Right. And so this average salary will be computed for all the 107 rows. And then guess what? We can now see an individual salary. We can also show you the average salary in the entire company. And then I can show you this very important metrics. Take your salary and deduct it from the average. And then from these metrics, you can know how far away are you from the average salary, above or below. All right, maybe I've put too many things on this. In fact, let me decongest this. I was supposed to really decongest this query. It's a lot going on this query. All right. Now, yeah, I think it starts right here. I'll skip here. Yeah. Let's address this part first. Let's forget about this. All right. So I want you to see that we are showing this is what individual salary. This is what? This is the total salary across the entire company, which is the 107 employees. So when we say salary, we are just showing the individual salaries. When we say sum of the salary across the entire window, no partition by means you're looking at the entire window, which means that 107 rows or employees are part of that window. So we are summing all their salary. There's a difference between this and this. This is just the individual salaries, and this is the summation of all the salaries for that window. And that's why we call this the grand total salary. And if I execute this, I think we now can understand employee ID. This is just return the column. We're combining first and last name with the space in between to give employee name. We understand this logic right here. We are returning the department ID. We understand that we are showing the salary. This is individual salary. And then this is the total salary in the company. Why is this value repeated across the board? Because all these 107 rows are part of the same window. So that calculation you've performed, which is what? Summing up all the individual salaries, 107 of them. We sum up all of this, we get this value. And this value is what we call the aggregated value. Is now being repeated across all the 107 rows in that table. So in the window function, the aggregated value, which is this, is reported for each row in the window. In a group by, the aggregated value is reported for each group. Right. This is very important. What is the definition of the window? This is it. It just simply tells you that this window involves all the rows in this table. How many rows are in that table? This exploration will give you. There are 107 rows in that table. And since this is an employees table, there are 107 employees. So all the 107 employees involved in this table constitute the window. So without a partition, you have one giant window, and all the rows in that table are part of that window. So I want you to see what happened right here. This is the individual salaries of the employees. This is a summation of the salary across the entire window, and the window involves all the 107 employees. So this is summing up the salaries of all the 107 employees to give you this grand total salary. Right? And since all these 107 rows are part of the same window, they get the same aggregated value. See that? So we can now compare an individual salary to the overall in the company. It is best when you do that from an average perspective, which is what I'm trying to do right here. So any question on this? This is just the individual salary. This is summation of all the individual salaries, which is 107 of them over this window. This is very important, and you see this difference. See that? And now if you look at this requirement, compare each employee's salary to the average salary in the company. It's simply gonna go right here and change this from sum to average. So we're keeping everything the same salary right there, and then we are now changing toward average salary. Let me first of all dismiss this part. I'll bring it back. I'm going to activate it. Dismiss this part. I'm going to bring it one after the other. Dismiss this right here. So this is now, we've changed the summation of the salary to average salary. So we are showing each employee's salary. We can now compare it to the average salary in the company. And this could be an important, are you below the average salary in the company, or are you above the average salary in the company? So this individual Stephen King, this is a salary, and then this is the average salary in the company. And you can notice that some people are paid less than the company average. Could be a problem. Right. So we're going to do that analysis in the next part. The part I kicked out is this part. So I'm going to kick out this part. And now we're asking ourselves, how much is your salary closer or further away from the average? That's a subtraction. Take your individual salary and deduct it from the overall average in the company. See, I'm always attaching the over clause to that average calculation, so that this average is done on the window. This is averaging the salaries of all the 107 employees. This is very important, adding this to it, this extension. So if I run this, we are simply taking your salary minus the average across the entire company to get this. Anyone that is negative, it means that that person's salary is less than the average. You see, like this example. See? So this person is actually paid less than the average in the company. And by how much, you can see the amount. This person's salary is this above the company average. This person is actually making good. See? And if you look at this, I think this is the Stephen King guy is the highest earner in the company. See their salary, and then see the average, see the amount by which they are above the average. All right, this is just some interesting comparison. This is the power of window functions. You cannot do this kind of thing in a group by. Right, because group by will not embrace all of these individual details. No, it is working at the group stage. Last time, the first example we did analysis by region and market. You see, we put all those data from the same region and same market together, but we did not see the individual roles in that analysis. If you're interested to see those individual roles while performing aggregation, then you must work in a window environment. This is us seeing individual information while performing aggregation. See, this is individual information, all the 107 rows, while performing aggregation alongside the individual stuff. That's the power of window function. See that? And this is an important analysis we are doing. We are comparing an individual salary to the average, and by how much is it above or below. Anyone that is negative means that that person is below the average salary in the company. And then they can tell you now to add a logic. That's the logic. I dismiss this one. We are using a case statement. When an individual salary is above the company average, what do? Return this above average. When an individual salary is less than the company average, you see the average, and I'm attaching the over clause to it. This tells you it's a window function because of this attachment. So if your salary is less than the average salary, is below, but then you see some individuals, the salary might be exactly equal to the average. So we just put exact average. So these are the three partitions, and that's the job of a case statement. Nicely done. We are using a logic to partition things. Let me just go over this again. So we are using this calculation right here, which is what, now this, you can use this one as well, or you can just make it easy. Just compare the salary. If it's above the average in the company, then above average. If the salary is less than the company average, then below average. If it's exactly equal, then exact. Now, if you run this, you see we are building a lot of insights. We are still having the luxury of seeing all the 107 employees. This is very important. You will not see this in the group by. Why seeing all the 107 employees? We did some aggregation. A single aggregated value was returned for each row. And then we did a comparison, take an individual salary and compare it to the average. If it's above, report above. If it is below, report below. If it is exact, I don't know if anybody had a salary that is exactly the same as the company average. Right, you see? So we don't need to be looking at these numbers. People just want to see these flags right here and see. It's a KPIs. You just want to see some indicators and you understand what's going on. You see the power of the case statement right here. Right. Again, very important, we are seeing all the 107 employees in the company. Right. This is very, very important. And this is all phase one. This is a repetition. Compare salary to the overall. That's a repetition. Compute salary. This one says compute the salary percentage relative to the overall. So take an individual salary, divide by the overall in the company, and then multiply by 100. That's a percentage. Right. And this is just some extra manipulations. The higher the percentage, the better the salary. See that? Because we are taking this relative to the overall in the company, this divided by this multiplied by 100. So the higher the salary, the higher the percentage. And this is the basis of building a pie chart. Remember a pie chart when you're comparing individual segments as part of a whole. Right, but then if you have too many areas to compare, it's not good to put on a pie chart. This is too many. Right? So the higher the percentage, the higher the salary. So 3.47% of the company's salary is going to this individual right here. This person's salary accounts for 3.47% of the overall salary in the company. See that? So the lower the percentage, the lower your salary. Right? This guy is a CEO. If I put the job title, you see CEO. And the power of this is that you can just go in and add more columns. I think there is a column where we can track the job title, the job ID, Stephen King. This is that individual. That is the president, right? That's the highest ranking individual in the company. Right. So I really want you guys to see this. Indication over clause is used to define the window. If nothing is specified, like the partition by, order by, we have a single window, and that's why we're doing in phase one. I want to keep it simple. Phase one, no partition by, no order by, so that you start seeing how this is playing around, the impact of this calculation over this window. Summation will always be summation, but what are you summing up? That's what this is defining. See, right? Let's see. Let me take you to phase 2 so that we can now switch the database and we go to phase 2. In phase 2, we're going to be doing something interesting. We're going to partition the window. And now this is tied to the question you asked, Alex, the idea of group by. So when you do partition by city, it goes through the grouping. It tries to, imitate the group by. But then guess what? Although you're grouping by city, you're still in a window environment. All these different transactions from that city will show up in the result. That's the power of a window. It's not like in this analysis where we group by city and we saw 3 rows because of 3 distinct cities. No, you're going to see much data showing up. All the 3 rows of other information from Arlington will show up. And then that will be a window. And that's exactly what we're going to see. Let me show you. On the phase 2, I will start increasing the content of the over clause. It's no longer going to be blank like what you had in phase 1. We're going to partition by city. Partition by city means you're splitting up your window into different segments. So they're going to be an Arlington window, a Shalford window, and a Guilford window. Those are the 3 cities we have in the data set. And then now the summation will be done for each window. You see that the summation has now been restricted. This summation will be calculated per city, per window, and the window has been partitioned by city. This is very important. I want you to see a huge difference in the calculation. And whenever you see a change in city, the value will change. So you're going to have that. Let me first of all zoom into what we call the Arlington window. Do you see the 3 orders that came in from Arlington right there? In the group by, we did just a count of the orders from each city together with the summation of the order amount. I'll keep going back to this. So we are showing the count of the orders in each city together with the summation of the order amount. If you look at the Arlington window, 3 orders from Arlington. And that's the same thing. So this is what the window function is using this. And then it is performing some aggregations and adding extra columns on this structure. Window function is preserving the original structure of the table, which is this. If you notice, all the window functions we've executed, they have this structure, 10 rows always. And then they are adding extra aggregation columns onto the analysis. That's the power of this window function. This is going to constitute what we call what? This is the Arlington window. Since we partitioned by city, this is the Arlington window. Now the sum of the other amount will sum this plus this plus this, and it will stop right there and give you the value. This, and this identical. It now switches to the Guilford window. It will sum this plus this plus this plus this and stop right there and repeat that summation. In fact, let me go to the output so you can see. Like, when you're dealing with window functions, understanding is key. You have to be able to understand. This is easy, is the summation of the order amount. How would that summation be done across this window for each city? So each window is defined by a city. So if I zoom into a particular city, I'm zooming into a window. This is a particular city, Arlington. This is Arlington window. How is this generated? It is this plus this plus this. Stop right there and report that value across the 3 rows in that window. You still have the luxury of seeing the 10 rows in that table. That's a key characteristic of a window function. You get to see the full picture while seeing extra aggregated values being calculated. This is so powerful. See that this summation right here is what that function is doing. It is not changing this behavior, right? But now what are you summing? That's where this comes into define. So this controls the behavior of this. It does not redefine it. It just controls the behavior. My summation starts here to here to here. Stop. Why? Because the next is a different city. This is the Guild Arlington window, and that value is reported. When you're studying this, just take up your calculator, add this plus this plus this, you get this value. And why is this repeated on this? Same window, same window. So all values all rows of the same window get the same aggregated value. We are done with Arlington. We go to the Guilford window, zoom into the Guilford window. This is it. How is this done? Summation of the other amount, this plus this plus this plus this. Do we get to this? No, that's a different window. We stop right there. This is a summation. And that value is this, and it is reported for each row in that window. So you see that the partition by is very powerful compared to the group by. The group by is showing you the distinct values on which you're grouping, distinct cities. But the partition by is showing you the full details of every transaction that belongs to that window. And this is it. So please, you have to be able to interpret and understand how these values are generated. It is a summation of the other amount, but we are summing it per city. That's the window. So we no longer have one window. If I dismiss this, we have one window. That's what we did in phase one. If I run this, see the same value is reported across the board because the calculation did not stop per city. No. And if you look at the city, just arrange in any order. But once you partition by city, see the result. The system will arrange it for you. See the arrangement, so that it helps you to understand the outcome. So it's this plus this plus this to get this. And since this is in the same Arlington window, the same value, it goes to the next window and resets. The function resets itself when it encounters a new window. Summation this plus this plus this plus this, and reports that same value across the board. Gets into a new window, Shalford, it resets itself, fresh start, and goes over again, this plus this plus this, and then reports that value. This is very powerful. If you can interpret these window functions, understand the behavior of the over clause without this is phase one, no partition by, you have one window. If you partition by, you have multiple windows depending on the number of cities you have. And always remember the luxury of the window function. You see the full picture. Every single row is returned. Nothing is hidden. You see everything together with the aggregated values you're computing. So everything together with the aggregated values you're computing. See, this is very powerful. Let's go back to the HRO. People can say, hey, it's not fair to compare salaries across the company. Let's compare salaries within each department. If all of us are working in the IT department, let's compare salaries in the IT department. Some departments pay more, of course, in the corporate, in an organization hierarchy, some departments pay more than others. So we can fix that analysis we did previously by restricting the calculation or the comparison for employees of the same department. See that? So I am the IT department. I can compare my salary to the average salary of employees in the IT department. If you're in the sales department, you compare your salary to the average, to the salary of the average employees in the sales department, just like that. You see? So we are now going to go to our window and partition it. See, this is me just showing you, write a query to calculate the total sum of salary department wise. It's just, see, I'm grouping by department, and I'm just showing the total salary. This is not a window function. You see, this is heavy summarization. Let me switch the database to HR. Right, and we have two tables. I'm going to come back to that. So I'm using the department IDs. You see, I'm just showing you each department total salary. You don't see how many employees are in this department. This is what a group by will show you. Right, you don't see, no, you don't get all the full picture of the employees in this department. It has just simply aggregated, and this is what it's showing, a single value for each group. That's what you get with the group by, and we're grouping by department ID. So you're going to show each department ID and a single aggregated value for that department. End of story. In Another context, I did show department ID, so you might not be happy with the department IDs. Show me the department name. So for department name, you will have to join the departments table to that employees. See, and it's going to make the analysis more interesting. So I'll be showing you the department ID alongside the department name, and department name is coming from what the departments table. You see, I had to join the employees table to the department table. So, and I'm grouping by this, which is the same structure like what I have in the select. So this is a much more interesting one. Now I understand that department ID 10 is the administration department. This is very frustrating. If you do this kind of analysis and send to people, this is not descriptive. What is department ID 10? You see, this is very important. So it's not a big deal. The department names are in the department table. Yeah, just go ahead and join it. Give people a full descriptive report, not quotes, and this is it. Okay, department ID 10, that's the administration department. Yes, we can relate to that, you see. Finance department is this, oh yeah, you see. So there's one employee in the administration department. There are 6 employees in the finance department. We don't get to see the full information of the 6 employees. Why? Because this is group by. In a window function, you will see all the 6 employees, the 6 rows of the 6 employees in the finance department. You will see the 45 rows pertaining to the 45 employees in the shipping department. That's the power of a window function. See that? So if you look at this, I want to fix that analysis. This is now a window setting. See what I'm doing? This is sum of salary. The same thing we did right here, sum of salary. But then I'm doing this over a window. And guess what? I am partitioning my window by department. You can do department ID, or I'm just using the employees. Let me go to this one that has the join. This one will just give you those IDs. I'm not a fan of IDs. I want to see department names, not department IDs. So I'll switch to the join one, which is this, so that I can actually show you the department ID and also show you the department name. See, this is more descriptive. So I am no longer comparing an individual salary to the overall salary across the entire company. No, I'm doing that per department. See, after we're going to look at average. Right now, we're just looking at the sum. So please take note that our over clause has been modified. This is phase 2. Our over clause has been modified. This is company analysis. We're looking at all the 107 employees in the company. But in this analysis, our window has been partitioned. So all employees in the finance department will constitute a window. All employees in the sales department, the shipping department, different. And I'm going to show you how this will impact the analysis. All right. So if I execute this, see what we're getting. We're getting the employee ID from this first name, which is this. We're getting the department ID and also the department name since we added the departments table to it and the salary. See? And then see what the system has done. Accounting, 2 employees. Once you partition by, the system will just arrange the window nicely for you. This just tells you there are 2 employees in the accounting department, you see, and you see every information about those 2 employees. In this previous analysis, in the accounting, I did this and count of the employees. If you run this, you will see 2 on the accounting. Where's accounting? Right here, 2 employees. And then this is a combined salary. But you don't see the names and full details of those 2 employees. Shipping department tells you there are 45 employees, and this is the combined summation of the salary. See, that's a limitation of the group by. Right. Anyway, not actually limitations. It depends on the analysis you're doing. If I go to this one with the window function, it becomes very interesting. If I just, let me just take you to the area of the shipping department that you can see from here. You see, these are all the 45 employees in that shipping department. You're seeing their names, you're seeing their employee IDs. You can add more. This is it. Very, very interesting. See, and the aggregated value computed is being shown for each value each row in that window. Now let's go back and analyze this. So we are summing up the salary for each department. We are controlling the behavior of the sum function. Sum the salary by respecting the window, and the window is defined by what? The department. So don't sum across departments. Stay only within the department and do the summation. So this is what? This is the accounting window. And the sum function will target the accounting window and do what? Sum up the salaries within that accounting window. Is what? Sum of salary. This is the accounting window. If you just pull up your calculator and sum up this plus this, you will get this. And it is repeated on this because that's the same window. Clearly, you can see that there were 2 employees hired in the accounting department. You know their names is right there. Their individual salaries have been summed up. This is what? Sum of salary. Why respecting department window is the accounting window. This plus this is this, and then we spread it across on this. Administration. Only 1 employee was hired in the administration department, Jennifer. And that's her salary. If you sum on that one salary, it stays the same. Now let's go to the executive department. These are top earners in the company. See, there are 3 executives in the company, Steven, Nina, and Lex. And these are the 3 salaries. Sum them up, you get this, and you spread it across for each row in that window. You see how we are able to control the behavior of the salary column, of the sum function. You see, we are right here. An aggregate function, but operating in a window environment. An aggregate function, true, but operating in a window environment. The presence of the over clause, it's a window environment. This is very important. I want you to see that luxury of seeing all the 107 employees. Right. And then you're doing that calculation and you're returning it across the same window. If you go to the finance department, these are all the employees that we hired in the finance department. These are their individual salary. This is a combined total of the salaries in the finance department. This function is very, very precise. It is respecting the window you've defined it. See, the summation is done per window. This is very, very important. Human resource, Susan is the only employee in the human resource. This is a salary summation of a single value stays the same. IT department, this is it. And it continues like that. Please, this is very important. When you spot the over clause, you're dealing with the window function. This is applied across the window. And if there's a partition by, the window has further been partitioned. You split the window based on the department. Right? And this is very, very important. You understand that if we remove the partition by, dismiss, guess what? This value will be the same across the entire window because it's just one window. If I run this, I've changed the analysis. I'm summing up everything, and the function does not stop based on the window. It's just one window, all the values qualify, sum them up, and then report that same value for each. Is it identical? But when you add your partition by, back add the partition by, the summation of the salary will be restricted to the department. That's the window. It's no longer, it's not a group, it's the department window. All right, this is very important. I think I should pause right here before we get into phase 3 and see the full picture of the partition and the order by. I want to stop right here. Any questions? Somebody did an interesting post on LinkedIn on this. So while you're thinking about the question, let me see if I can take you to LinkedIn. I will just start by reading. Maybe I'm going to copy that article and share with everyone. I do spend a lot of time on LinkedIn. Right, it's actually a very powerful library. There's a lot you can learn on LinkedIn. If you're a professional and you're not on LinkedIn, you're really, really missing out. Towards the end of phase 1, I'll start, putting pressure on you guys to set up your LinkedIn profile. So this right here. So window functions apply aggregate and ranking functions over a particular window. And the window is what? The set of values, set of rows. The over clause is used with window functions to define the window. This is very important. So if you spot the over clause in a query, it is used to define the window. And there are two things that go into this space. The first one we've seen partition by. The next one we're going to see in phase 3, which is the order by. So the two things that can go into a window, right? And let me go back to that stuff. So the over clause does two things. If you use a partition by, it's going to partition rows into form set of rows. That's the goal of the partition by. All right, and then the next one we're going to see in phase 3 is the order by. And this, you're basically just ordering the rows within that particular window. And there's another interview question. What's the difference between the order by you place inside the over clause and the order by you place at the end of your select statement? I will address that. Yes, we're going to talk about that. I don't know if you guys are ready for the phase 3. This is the last phase, so that we're going to see the full picture of the over clause. We moved from being blank to having a partition by, and next we are adding an order by. And you have to understand that it's the same concepts. The order by right here is simply sorting the rows within a given window. It is not sorting the entire result set. The order by you put right here sorts the final result set of your query. This is very important. The order by you put inside the over clause is with respect to the window. So it is sorting the rows inside the window, not the final result set. This is very important. I've had this in an interview. Right, this is very important. And this constitutes the full picture of the over clause. You can partition by, you can order by. And the order by does the sorting inside the window. Right, this is very, very important. Right, and it's something we're gonna discover. So let me just go back to that LinkedIn stuff. You see, over clause does two things: partition by to further split your window into different windows, into different mini windows. Order by to sort the rows within your window in a particular order. If partitions aren't done, then order by orders all rows of a table. Right. So this is just, now let's go back and just explore the presence of the order by. What happens within a partition by city. So let's run this. Oops, I have to switch the database. And then next execute this. So we are still looking at the sum of the order. It could be any aggregate function. Maybe I've used the sum a lot, but you have to understand that it could be any of these aggregate function: average, max, mean, sum, count. I'm just using sum throughout, but I've also used the average. But you have to understand that depending on the analysis you're doing, it could embrace any of these aggregate functions, right? So let's go ahead and run this and then see what happens. Let's try to understand what has occurred. The fact that we have a partition by city, what would be your first reaction? Zoom into each city. This is the Arlington window. And that's an easy way to understand this. Once you see a partition by, just go to the output, zoom in to one of the partitions, one of the window. Right. Then there's an order by, order date, descending. So how has the system sorted the three orders from Arlington? It has sorted them based on the order date. See right here, it says descending. All of this is 2017 and all of this is April. So in a descending, you're looking at the most recent date, 11, 10, and 2. If you want to understand the impact of this, switch this into ascending, which will be the smallest date to the current date. If I run this query, you're going to see that it has resorted the, you have to interpret it per window. This is very important. Whenever you see partition by, don't just go look at the full picture. You're missing the point, you see. If you see a partition by city, zoom into the query and focus on a given city. The system will always align it so that you can zoom into it. That's the first thing. We've interpreted this. So I'm now showing you the Arlington window. That's the meaning of partition by city. This is Arlington window. This is the Shalford window. This is the the Guilford and the Shalford windows. So let's zoom into the Arlington window. What is the impact of the order by in the over clause? We are ordering by date. So go to the Arlington window and then sort the rows based on the order date ascending. This is the order date. You see, on the 2nd of April, 10th of April, 11th of April. So we've sorted these 3 orders in the order in which they came in. That's the power of the order by. Inside the window, I'm not looking at the full overall picture, no. The sorting is done inside the window for each specific city. This is very important. So you have to zoom into the city first, go through the sorting and confirm that it works. Yes, it is the smallest to the highest date. If I switch this to descending, like what we had previously, you have to see that the order will change. This order is now showing up first because of this, followed by this, followed by this. And then if you go now to the Shalford window, zoom into that window. This is the 25th. Then we go to the seat, we go to the 4th, we go to the 1st. If I switch this to ascending, then you're going to notice that it will be reversed. You see, if I zoom into that window, I'm not looking at the full picture. You miss the point. You have to zoom into the window. There's a partition by. So follow through with the partition by. Let's look at the Shalford in this case, or the Guilford window, this one. And you see, 1st, 4th, 6th, 25th. These orders have been sorted in the order in which they were placed. You're looking at the orders table, you see. And same with this one. In the Shalford window, the orders have been sorted in the order in which they came in. This one came in on the 3rd, on the 5th, on the 20th of the month of April of the year 2017. This is very, very important. So now let's make sense of this. What is this doing? Can somebody explain to us this and this? And there's something very powerful when you introduce the order by, you get a cumulative effect. What they call a running total. And businesses love that a lot. If you see right here, this simply tells you that start the summation on a given date. You're starting the summation on this date. So this becomes the first value in that summation. This is it, keep it. How do you get to this? You take this plus this to get to this. How do you get to this? You take this plus this plus this to get to this. And that concludes that window. Let's take note, in the presence of an order by, we have a cumulative effect. We have a running total. If you're dealing with total, if it's average, we have a moving average. And businesses like to do this. Your annual income is a summation of all your income. For example, we are currently we're almost concluding February. So what is your year to date? That's what that's the terminology they use. Right now, your annual income will just include what you've made in January plus what you've made in February. That is a running total. That's a cumulative total. When March comes in, it's going to add March. And you see the total keeps growing. If I dismiss this partition by, maybe that's where we're even supposed to start, dismiss this. Right. I'm not going to zoom into any city, no window. I'm going to consider everything as the same. Now, this is an excellent way to view that. Please take note now, we don't have any partition. Right. Everything is one window. Let's interpret the sorting. We are sorting by order date. So you see that the dates are sorted 1, 2, 3, 4, 5, 6, 10, 11, 20, 25. So we're telling the system that begin the running total process on the very first order that came in on that date, on this date. So we're going to pivot on that. See, this is the start point. Start on that. This is like the salary you made in the month of January. Now we are in February. What will be the combined salary is what you made in January plus what you made in February. And then we get to March. What is a combined is what you made in January, February, and March. That's what a running total, a cumulative total. That's how you build it. Always remember this. Whenever you usher in the order by, it generates the cumulative effect or a running total effect. This is very important. If I remove this, we will not see a cumulative effect being generated. It is just this plus this plus this plus this plus this plus this, and then reports that value throughout. There's no cumulative effect, you see. In a cumulative effect, you're going to start with this, keep it the same this. When we get to this, we have to sum this plus this to get this. And then it's building gradually. So take note. And when you're studying, I want you to vary this. Put in the order by, dismiss the order by, and see how the system is processing it. That's how you know a cumulative effect. It starts with this. If you change the order of a date, it's gonna begin with this one. I'm flipping the table, so it's gonna begin with this. See, it's gonna begin with this one. So it's gonna start from this and then start building the total. See, now this 20 feet is the see, and that's the start process of the cumulative effect. We get now to this. So this order came on 20 feet. On the 20th, we now take the 20 feet one and the 20th one and sum it to get the next in the cumulative effect. So at this point, we have this plus this, we have this. At this point, we have this plus this plus this. And then we'll go all the way to the bottom. We've exhausted it. It has to be this plus this, everything all the way. See? So the order by, that's the effect. It generates that cumulative effect. Let me link this to the HRO so that we can understand. I think I have to go back on this. We have the partition bar and the order bar. Let's use salary so that you can see how this works out. I think after this, we're going to take a break. Oh no, I think let me just go. Yeah, I want us to take a break. Get to the ranking so we can work on something new. Okay, let's link this to salary. Again, I'm just going to interpret this. This is the same, sum of salary. Yes, we have an over clause and we have a partition. So again, we are partitioning by department, and then we are sorting by the employee ID. So in a given department, let's sort the employees based on their employee ID in descending order. So when you run this query, you have to first of all take a break and look at the department. So zoom into the department. For example, you see this department, only one employee in that department, Jennifer. I think this is the HR or something. And then on this department, you see these are the number of employees in that department. Go to the employee ID. Why was Luis listed before Jose Ismail? It's because of the employee ID descending. Luis has the highest employee ID, 113, 112, 11, 110, 109. You see, if you switch this to ascending, then Nancy will be listed first in that department. So if I run this query again, this is very important to spot. So if I zoom into that department, this is the department right here. This one, if I zoom into this, so now Nancy is first because I'm I'm sorting by employee ID ascending, the smallest employee ID to the largest. This is very important. And now, since we've talked about the presence of the order by generates a cumulative effect, we are pivoting on Jennifer's salary in this department, and then we stop right there. You see, just one person. But when you go to the next department, which is this one, department ID 100, we start with what? Nancy's salary. That's where the cumulative effect begins. Now, when Daniel's salary comes in, we add it to Nancy's salary to generate this. When John's salary comes in, we add John's salary plus Daniel's salary plus Nancy's salary to get this. You see, it is growing. That's a cumulative effect building up. And when we get to the last person in that department, it stops. Right? It stops right here. So now we get to a new department. This one, right here. This is a new department, two individuals in that department. We start to pivot the salary on that, add this to get to this. We get to a new department, and the first person in that department is Michael. We begin with Michael's salary, just Michael and Pat in that department. So we begin with Michael's salary. We'll get to Pat, we add Pat's salary to Michael to get this. And that's it. The function resets since we're getting to a new department. That department is department ID 30, begins with Dan. Then you see the salary is the same across the two columns. You see? And then we start adding Alexander's salary. You see, that it keeps growing as we're adding. That is a cumulative effect. It's felt when the order by is introduced into the picture on a window function. This is very, very important. If you don't want to see that cumulative effect, don't put the order by. Right? This is very, very important. This is another one on Adventure Works 2022. We are doing partition by customer ID. One customer can place many orders. So we're going to, each customer will constitute a window, and we want to sort the orders in by what? Sales order ID. So in this case, you have to zoom into, this is a customer. All these orders were placed by the same customer. You see this? It's the same customer ID, 1, 2, 3. Right. Since we are having an order by sales order ID, this is sorted based on the sales order ID ascending. And then you see the running effect. You add, you start with this as a starting point. This. How do we get to this? Is this plus this to get to this? How do we get this? Is this plus this to get this? And that's how we are done with that window. This is a different window since a new customer ID showing up. See, and you repeat the process. If you don't want to do cumulative total, dismiss the order by clause. This is very, very important, right? And these things are common. This is just an explanation to show you what is going on. So for a running total is what? Current plus all the previous. For the first row, there's no previous. So if I run this, we are doing partition by city. You see, I always go and interpret what we have in the over clause so that I understand the structure. Partition by city, this is the Arlington window. And then we are sorting by what? Order date. You see the order date, this is what? Ascending, this, and this, in that order. So this is the current. Cumulative means what? Current plus all previous. This is the current. There is no previous, it stays the same. This is the current, there's no previous, stays the same. So that's the amount. If we go to this, this is the current. What is the previous? This is it. So current plus all the previous. Current, there's just one previous, which is this. So current plus this previous gets this. If you go to the third row on the Arlington window, is this one. This is now the current plus all the previous is this plus this plus this to get to this. And that's how we are done with the Arlington window. When once we get into a new window, the function resets itself. That's a key word you should use in an interview. the function resets itself after each window. We are now in the SHA-4 window. You see the function reset itself. This becomes the current. There's no previous. We keep it the same. In this row, this is the current and this is the previous. So how do we get the cumulative? It's this plus this to get to this. This is the current. How many previous? This. So we have to take this plus this to get to this. This is the last row in the Guilford window. It is this row plus all the previous to get to this. And the function stops right there because we get into a new window. It resets itself, goes all the way to the beginning and starts in a new window. This is SHA-4 window. This is a current, no previous. It is simply this plus 0, which is this. This is the current for the next row. Previous, this plus this to get this. And then for this is the current, the previous is this and this. So this plus this to get this. You have to practice this, right, so as to understand. Right, I'm just going to skip this. And that's the concept of running total when an order by is used in the over clause. It is you are summing the current and all the previous. If you use an average, the average is computed by sum divided by that, and that's what we call a moving average. Now you don't even need to put this, right? You can just do the average function and to perform that. And businesses uses a year to date. You start summing at the beginning of the year all the way to today's date. That's the meaning of year to date. Year to date sales, the sales at the beginning of this year, first day of January of this year, all the way to today's date. That's a cumulative process. In month to date, this month is January, it's February. The sales first day of this month, all the way to today's date. That's the month to date sales. The quarter to date, this is the first quarter, which began. A quarter involves three consecutive months. January, February, and March constitute first quarter. So total sales in the first quarter will be the summation of all the sales that came in first day of January all the way to the last day of March, January, February, March, or all the way to today's date. The reference is always to date. It's a quarter to date. As of today, right? So as of today, sum up all the sales from the beginning of the year all the way to today's date. Beginning of the current month all the way to today's date. Beginning of the current quarter all the way to today's date. These are cumulative processes. Right, and these are the definitions right here. You can just explore those to make sense. Right. Any question? Let's take a break. And when we come back from the break, I'm going to move to this segment right here. So I'll focus a lot on average and summation, but take note, you can do max, you can do mean, you can do count. And the most important thing is being able to spot the over clause. And that's how you get to know, hey, I am actually dealing with a window function. Right. And this is an aggregate function in a window environment here on this side, an aggregate window function. Right. So that these definitions are actually easy. This is an aggregate window function. Any of these window function, any of these aggregate functions used in the presence of an over clause, you are looking at an aggregate window function. Right. We're now going to step into the true window functions, which are these ones right here. Roll number, rank, dense rank. We're going to look at those three after the break. Let's take a 20 minutes break and we're going to start looking at these ranking functions. Okay, let me set the timer. Let's go for a 20 minutes break. Okay, see you after the break. Okay, welcome back, everyone. Okay, so the next set of window functions we're going to look at is the ranking ones. So from the name, you can easily understand what they're doing. We're going to be ranking the components within the window based on a certain criteria. For example, we could be asked to rank employees in the same department based on salary, right? So there are three possibilities that are popular. We have the roll number function, we have the rank function, and we have the dense rank function. By the time we're done with these three, you're going to see each is addressing a specific aspect of the ranking concept. So let's get into that. We're going to begin with a simple one, row number. So this is a function that simply gives a unique number to each row in a window. This is very important. Unique and then sequential. For example, the first one gets row number 1, row number 2, row number 3. There's no skipping. So unique sequential numbers. Right, that's very, very important. Right, let me see what this gentleman put right here. Assigns different rank numbers when the values are the same. Yeah, we're gonna get to the details of the difference, right? So the row number function is the easiest. It simply just goes to each row and assigns a row number, unique and sequential. So beginning at 1, then 2, 3, 4, just like that. So the row number will reset for each partition if the partition by is specified. We're going to see how that works. And for the benefits, I'm going to explain this when we are looking at the topics on week 7. Right. So let's take an example. First example on the row number function. So we are back to HRA. I want to use the salary information, and I want to use the row number function together with the partition by, sorry, the over clause. Let's look at the basic. Let's just look at the row number function in a window environment. I must point out this. Row number, rank, dense rank, nothing is passed into them. It's unlike the aggregate functions we saw previously, where we had to average on a certain column using max. You see, this is normal. In the ranking, the parenthesis is empty. This is very, very important. Right. In all of these ranking functions, nothing will pass right here. Right. This function simply brings in a row number and assign it to each row in the window. Our window is simple, no partition by, no order by. So we are looking at the total 107 employees in the company, and we're going to be, assigning row numbers on them. Since I haven't defined how the rows should be sorted in a window, that should definitely be a problem. Right. If I go ahead and execute this, I get an error. The function this must have an over clause with an order by. Exactly. So you want to sort things, you have to define the way the things will. You want to number things, you want to rank things, you have to define the way the thing will be ranked. What gets row number 1? What gets row number 2? Row number 3, and so on. So this is very, very important. There's a gentle error right here. We're going to see how to improve that. So this is the fix. I go into the over clause and I tell the system I want you to sort the values in the window based on salary. So the employee should be sorted based on salary in that given window. Highest salary, of course. Now this is good because row number 1 will go to the employee with the highest salary. Row number 2 will go to the employee with the second highest salary, and just like that. So we now have a structure. We've defined the ranking is based on salary. Please take note, this is previously you used to see numbers right here. These numbers are part of the interface. Right, that's on a column. If you execute a query, the numbers you get are just part of the interface. That's not a column. What we've added right there, row number, it's an actual column. Right, so there's a difference. Let's look at the employees, the departments or employees run this. These numbers you see right here is not, this is the very first column. This is not part of the table or the result. But what we've added right here is a column. And this column is built using the row number function. And this one right here has a meaning. It has a business meaning. This is the employee with the highest salary because we applied the row number function over the window and we sorted the values in the window based on salary, highest to the lowest. So the employee with the highest salary gets row number 1. Employee with the second highest salary in the company gets row number 2. If I switch this to ascending, then I want to rank based on the smallest salary. So the employee with the lowest salary will get row number 1. That's all about the row number function. It's just ranking. And this is what? Unique sequential. There's no skipping. You see, it begins at 1 and grows 2, 3, unique sequential numbers. That's what the row number function at. Now you understand why it was very important to add an order by. If you remove this, you've paralyzed the row number function. It doesn't know what to do. What row gets row number 1? We haven't defined it, so you get an error. The function row number must have an over clause with an order by. We have the over clause. What are we missing? The order by. So the order by tells the system how the rows will be ranked. So we define the structure, order by salary. In this case, let's go back to descending. So we are expecting the employee with the highest salary to get row number 1. And that's how you rank employees based on salary with the first function row number. That's why we call them ranking functions. It is performing a ranking exercise based on a particular target. The target here is what? We are ranking based on salary. See, highest to the lowest. So you can now interpret this. Stephen King is the employee with the highest salary to get row number 1. See that second highest is actually tied. But then if you notice the definition of a row number function, it says unique sequential numbers. These two individuals have the same salary, but we're going to give them different ranks. This is very important. Right. So gradually we're going to exhaust all of this. And then the difference between these three will be on how the tree ties. See, for the rank, for the row number, it keeps it simple. These two people have the same salary, but we're going to give them different rankings. And that goes back to the definition of the row number function. It assigns unique numbers, unique sequential numbers. This function assigns a unique row number to each record in the window. This is very important. If two employees have the same salary, the row number function will give them different ranking. This is very important. We are already putting together the difference. If you're asking an interview, the difference between the row number, rank, and dense rank, they differ in the way they treat ties. So this is a tie right here. These two employees have the same salary. Guess what? We treat them different. We rank them. This is second, this is third. If you go below, you see other examples. If you look at this segment right here, all of these employees have the same salary, but see, they have different row numbers assigned to them. So that definition is very important. Unique row numbers are assigned to each row in the result. Even if there's a tie, see, all of these 4 employees have the same salary. We are ranking based on salary. The system gives them different row numbers, different ranks. This is very, very important, you see. So in this, we did not partition by. We can now do a very interesting example. What if we partition by department? This is a company level. We are treating all the 107 employees belong to the same company. No partition by, so all of this is one window, one giant window. All right, I think it's better to compare employee salary based on their department. I think So if we now do a row number per department, so we're going to partition by the department name. So see what we're going to add in the over clause. We add partition by department. And then we maintain the sort, the order by. This is very important. If you remove the order by, you've paralyzed the row number function. It cannot do its job. You have to remember that. So you have to always make sure that if you're using the row number function or the rank function or the dense rank function, there must be an order by in the window. Right. This is how you define the structure so that this function just attaches itself to what you've already defined and now start assigning those row numbers as the rows are presented. So the presentation is what? We are sorting by salary, descending order within each department. Why there's a partition by, right? See, and if we run this, execute. If I go to the accounting department, these are the two employees in the accounting department. This salary is higher than this. That's why this person was listed first. Row number 1, row number 2. You see that the row numbers are not continuous. There's a break due to the partitioning. That's how you get to know if a partition by was used or not used. If a partition by was not used, then the row number will be continuous. If I dismiss this, I go back to what we did above, the row numbering will be continuous. There's no reset. See, this is how you know that the partition by was not used. The row numbering is continuous. If a partition by is used, the row numbering will reset after each department in this case. See, so after every department, the row number function resets itself. See, this is the accounting department. This is a different department, so I'm not going to include that. This is the accounting window. You see the row number function, it ranks those two. This salary is higher compared to this. Administration department, just one person, that's the ranking right there. Executive department, 3 employees, rank them based on salary. We have this up. This is outright the highest. These two are tied, but remember the the row number function gives different numbers to each row in a window. Unique sequential row numbers. This is very important. Finance department, this is the finance window. And there are 6 employees in that window, in that department. And this is how we rank them based on salary. See that? So this is a much more better comparison. We are comparing the salaries per department. Human resource, just one person. IT department, these are the 5 employees in the IT department. And this is the ranking. See that? This is it. These two have the same salary in the same department, but they get different ranking. That's because we are using the row number function. And in an interview, this is what they want to hear. Right? The difference between the row number function, rank, and dense rank is based on the treatment of ties. Right? The row number function assigns different ranks to the rows, even if there's a tie. See? Now the classification, the ranking is done per department because of the partition by. This is really, really interesting. You can use this to solve a lot of questions. There is an interview, there's a question right here in this, talks about the third transaction of every Uber rider. You place a ride in Uber, and we are interested to see just a third transaction. There's an Uber example. Yeah, I think during the lab on Wednesday, we're going to go over that example. There are several examples that use window functions, ranking. This, let's see, there's an Uber example that talks about the third transaction of an Uber. Yeah, this one right here. You will have to use any of the window ranking functions, rank the rights of a particular Uber rider. So you have to partition by user ID. See, this is the data you have right here. So this is the same rider. See, you have to take all the rights done by this same person, put them in one window, right? And then use any of those ranking functions, like a row number function. You rank them based on what? The date. In this case, you use the date. How do you differentiate that this right came before this one? There's a date, transaction date. So you have to order by transaction date, descending, to know no, ascending to know which right came before the other, right? And then I'm going to show you now how to extract the third one. See, this is very important. So these solutions are steps to solving very powerful questions in SQL. All those ranking questions, we do them with the window function, either row number, rank, or dense rank. I can tell you now to show me the employees, the top two employees in every department. Top two employees in every department. What is the strategy? This is already 90% done on that question. Top two employees based on salary in every department. I've already ranked the employees based on salary for each department. In the accounting department, this is what I just need to extract. In the administration, is just one, that's the person. In the executive department, we're going to extract this person. In the finance department, we're going to extract this, you see. So you're going to see these kind of questions. In the IT department, these are the two we need. Right? You have to do some form of ranking. And when you're ranking, you want to include everybody in the table. You cannot do this ranking with a group by, because a group by will give you the aggregated copy. You want everyone to participate, and then you do the ranking, and then you extract just what you need. See that? This is very important. So these functions have a lot of questions you can solve in this using this knowledge of window functions, right? So I really want you to understand this process. We started off by doing this window function row number without the over clause, without the partition by. Of course, we know this is mandatory. Over clause must be present in the window function. If I dismiss this, I will get an error. I'm using a window function without the over clause. The function row number must have an over clause. With the over clause, it's not enough. Execute, you've solved that part, but you've generated another error. The row number function must have an over clause. Order by. You have to understand that the goal of these functions is to rank things, and things are ranked based on a requirement, based on a criterion. How do we address or implement the criteria for ranking? We use the order by. Right. So if you now put in order by salary descending, we have now presented the data in this window in a particular order. Now we can now attach the rank, this row number function to that structure. We have sorted by salary descending. So the employee with the highest salary gets row number one. Row number two goes to the employee with the second highest salary, and just like that. We've not partitioned by anything, so the numbering will be continuous, unique, sequential numbers. It's very, very important, you see. So when you're studying, always try to dismiss certain things and then see what happens. And that's how you build a solid understanding of this concept. Right. So this is very important. A row number is a window function, and by virtue of it being a window function, it must have an over clause. This gives you an error. Understand that you are missing the over clause. We bring in the over clause. This brings another error. It must have an order by, because we want to rank them. It must be a structure which this function we use to do the ranking. And that's how we end up with this order by salary descending. And finally, we've provided everything that function needs to do its job, and it gets the job done. See that? So this is very important. This is a row number per department. We've seen that. What is this doing? This is row number order by salary descending. It's the same thing, right? Same thing, right? Now, by using the partition by, we reset the numbering to 1 after each partition. Let's partition by department name. So it's the same explanation. We are using the order by is present, order by salary descending. That's how we are going to be arranging the employees in the window based on their salary, highest to the lowest, within each department, since we are doing partition by department. So when you see the row numbers, you have to interpret it within a window. This is the accounting window. The two employees have been ranked. First rank goes to the employee with the highest salary. Of course, this is bigger than this. Right. Let's zoom into the accounting department. Oh, sorry, the finance department. This, see, we have 6 employees in the finance department. Nancy has the highest salary in the finance department. This is followed by Daniel and see all the way to Louise. That's the ranking. These are ranking window functions. And this usually is a step to solving a problem. It's not the final solution. Right. So we are covering this as a step to solving potential questions with the SQL language. Right. So I want to go back and reiterate this. The row number function assigns unique row numbers to each record in the window, to each row in the window. And these numbers are sequential. So 1, 2, 3, 4, just like that. Right. Any question on the row number function?
I had a quick, I had a quick question about because like let's say in the over clause, right? Because usually when you use the select, for example, when you're, let's see, let me go back to, for example, you go back to 1 second. That's the example I was thinking of.
Yeah.
For instance, the exercise which you did, the row number by department, right?
Row
I
number
can
by
see like in the
department.
over clause it says
Yeah.
partition by department name. So like it's not you don't have to use a separate to kind of like separate, for example, the partition by department then comma order by. So that's, it's not a
Oh yeah.
necessity.
Yeah.
This when
That's a
you
very
use
good point.
the over clause.
Yeah, man, that's a very good point. Yeah. At the beginning, you will definitely be tempted to always put like a comma like this. Yeah, but then with time you learn that that's an error and you're gonna fix that. I made
Hello?
this error. So can you hear me? Hello, can you guys hear me?
Yes.
Yeah, looks like Alex. Can you hear me? Alex, if you cannot hear me, can you sign out and sign in again? It looks like the audio issue is coming from your end. Let me see if I can send a message. So this is the question Alex was asking. In the over clause, we usually put the partition by and the order by. You don't need to put a comma, right? And of course, depending on the question, you can partition by more than one column, right? You can also order by more than one column, but the comma is not needed. If you put a comma, you're gonna get an error. See, if I put a comma right there, I get an error. See, that's an error. I just have to dismiss the comma. So just take note, right? On the over clause, you cannot separate the partition by and the order by with a comma, right? I want to give one example. I will start by demonstrating this concept in with the visualization. Let's go to Global Superstore. All right, let's take an example. We're going to solve this together. Let's go to Global Superstore. Let's use the orders table. It's similar to equation we've solved today. All right. So on Global Superstore, I want to use the orders table. And I want us to track down the total sales across the different subcategories. Total sales across the different subcategories. All right. And then let's rank the sales from the highest to the lowest. So total sales across the different subcategories. Here we are looking at the full picture. Right. Let me just make this clear. We are looking at the full picture. I will give you a list of columns that we're going to put in the full picture. So select star from. So okay, Alex, you're back. Hopefully you can hear me now. So I was explaining. Okay. Oh yeah, I was explaining this. Yes.
Nothing.
Oh, can you hear me?
But it's fine. I have two screens, so I can hear you from one screen. So
From the other one. Okay, cool. So yeah, so this right here, if you put a comma, you're gonna get an error. So in the over clause, you cannot separate the partition by and the other by with a comma. You get an error, right? So it's something that you once you do it the first time, you get an error. Just you remember it and avoid doing it the next time. All right, so they just keep it simple, and you can also partition by multiple columns. It depends on the equation you're solving. You can also order by multiple columns. But I think when it comes now to ordering by multiple columns, you need a comma. You state the first one, order by this. To bring in the next one, you put a comma and order by. Same thing with partition. For the partition by, you partition by the first column. To put the next one, you put a comma and you state the next column to partition by. That is allowed. But just to put a comma between the partition by and the order by is not allowed. Right. And then I wanted us to look at this. So I'm taking you back to the Global Superstore. All right, I'm going to list out some columns that we're going to explore together. Let me do the version in Tableau, but I will rather want us to do this from a window perspective and throw in more columns and see a greater depth of the analysis than just the top level. So if I do this in, let me just dismiss this for now. Change this to Global Superstore. And then I'm just focus on the orders table, right? That's the equivalence of doing like the select star from the orders table. That's the data right there. And now, so Tableau, just like every other visualization, it will do the grouping stuff. This is the group by. So I want to show each subcategory. Where is subcategory? This is it. I want to show each subcategory, and I want us to look at the total sales across each subcategory. All right, anyway, let's begin with the category, and then we further break it down to subcategory. This is a hierarchy, you see. Then I'm going to bring the subcategory right here. Yes. So within each category, I can then sort. And if I want to make you understand this better, I can just add some colors. Most people will appreciate this better when they have colors. So if I just go in there, I want to color by the category, just drag category to the color segment, and we get this, right? Now, so this is the equivalence of a group by analysis, right? This is equivalence of a group by analysis. If we want to do this in SQL, we are looking at the total sales across each category and subcategory. See that's the title of that. So if I transform this into a title so we can use it to do our analysis, this will be total sales by category and subcategory. In this case, you don't need a window function to address that. But if you want to go deeper, total sales by category and subcategory, if you want to go deeper, you're going to need a window function. So if this is a requirement you get, then a simple group by will solve this. Show me a category, then show me the subcategory, and then do the summation of the totals. See? So I'm going to begin this. This is category. Show me the subcategory. Right. Then the next one will now take the summation. We are tracking total sales, not just sales, but total sales. The table gives us the sales. I need to target that and sum it up. So this is where we apply the sum on the sales column in order to generate total sales. So this right here will give us the total sales. Execute. I need a group by. So we understand that we need a group by. We have to group by all the non-aggregated columns in that list. So we have to group by all the non-aggregated columns in that. So I'm going to take this the first non-aggregated, the two of them. This is the first one. This is not enough. If I run this, I still get an error because I'm missing one non-aggregated column. I have to bring this also in the picture. So those are the two non-aggregated columns. This is what we get. So this is showing you all the 17 combinations of category and subcategory. And then it is showing you the total sales across the board. And the 17, these are the 17 marks, right? There's 17 of these. Right. Now, if you look at this, if you're now told to rank this based on the total sales, that's going to be a different kind of analysis we need to perform right here. If you clearly see, if I go to this visual on the furniture group, the chairs subcategory has the highest total sales. Let me just activate the totals right there. See that? So if you're given a question, return the top two best performing subcategories in each category based on sales, based on total sales. You have to do some form of ranking. This is not going to be enough. You have to do some form of ranking. Right. And so in that case, I can now take this. I'm going to copy this and put it right here. This will be done on some form of ranking. Let me define that. I have to get the sales, sum of sales. Let's add this over clause. I have to dismiss the group by. For me to dismiss the group by, I need to put an over clause right here, telling the system that this is not going to be done. The summation will be done over the window. See that? And I can put the original sales before getting the summation. And that's the power of a window function. You can throw in a lot of things. And you have to understand that all these rows will show up. See that? All those rows will show up. And then if I now want to do that structuring, I have to do it inside here. I'm going to partition by category. Let's start with that. Let's partition by category. If I just run this without partitioning, we understand what will happen. The totals will be summed up. You see, these are the individual totals. It's going to be summed up from top to bottom, and this is the general value we get. So this summation is across the single window, and all these 51,290 rows are part of the window. See that? So it will sum every single one of these all the way down, and you get this. And since it's the same window, we repeat across each row. A window function returns an aggregated value. This is the aggregated value for each row in the window. If you don't restrict your window, you get every single row in that window. And these are all the 51,290 rows we've seen, and that is the aggregation right there. If I now want to partition by category, I am now going to change the way the summation will be done. The summation now will be done for each category. So this is the partitioning, and the system will even help you to show you the result such that you'll be able to zoom into a particular category. Right, so if I run this, you have to understand that the summation on the sales is going to change because we've redefined the window. I execute this. Yes, this is actually taking a long, still processing. So when you run a query, and if you look at this button that is next to the execute button, you see it's busy. The query is taking a while to process. And if you go below right here, executing query, the query is still processing. You have to understand that there's a lot of work to be done because the system is visiting each category. In this chart, each category: furniture, office supplies, technology, and it is doing the summation of the sales, total sales. And that value will be reported for each of the 51,000 something rows that we saw. Is that stuff? This is it. Query executed successfully. What is the result right here? You see that? And if I zoom in, this is more in-depth analysis. The result is completely different from what we had in this. This is just a regular group by. I can also add this into the partition. So a window will be defined by a combination of the category and the subcategory, similar to what we have in this. So this right here, that's a combination, furniture and chairs. But instead of seeing just one bar right there, which is the aggregated, it has pulled every order that came in for furniture and this chairs subcategory into one. In a window environment, you're going to see the individual orders that we put together. So if I expand this window by adding another column, this is permitted. You have to put a comma and then you add the column. So our partition by is across, it's just like the group by category and subcategory. But now this is a window environment. Our window is now defined by a combination of category and subcategory. So each unique combination of category and subcategory constitutes a window. This is also going to take a while to process. I'm just going to wait for this to show up so I can compare this value right here. You're going to see this result shown for each row of the furniture and chairs combination. Right, this is very important. Let me just go to a new query window and type this. Give me all orders that came in for a furniture and chairs combination. Right, that constitutes a window in my definition to view orders. Right, so if I go right here and put the where clause, The first is what? Category equal to furniture. Just copy the value from this. That's the first. So this is a window in that analysis. First window, category is furniture, and then subcategory. The subcategory, I'm going to need a square bracket right here. Subcategory. I don't know why my IntelliSense is not working. Subcategory will be equal to chairs. This right here is one window. If you take note, the partitioning I'm doing right here is partitioned by category, subcategory. So one particular combination for category is furniture, and inside that we have chairs as a subcategory. So this right here constitutes one window. So one window has what? 3,434 rows. So when you put the summation on the sales, it's going to sum up that. And this is exactly what we're doing in this. I'm going to scroll down to furniture chairs. This window you see right here, this is a window for furniture tables. And I can check on the chart, furniture tables. You see this summation right here. 757,000. Come right here. That's the same number you see. But then it's showing you all the orders that came in for that. So in this picture, it's a group by mindset. All the orders have been summed up to a single value per group. And the group is what? Furniture chairs group. In a window function, you're seeing the individual orders that came in. I can even go ahead and add the order IDs. When an order is generated, an order ID is also generated. I can show you the individual orders that came in, the individual order IDs for each of those order combinations. This is the power of the window function. Right here. Order ID. No, it's not. It's just like this. Order ID. Run this. The first one that printed out is this. The one we're looking at is furniture tables. So I'm just going to go to that query and fix it. Furniture tables. That was the first window in that output. Furniture tables. And this is it. So furniture tables has 861 rows. This is the rows that will show up in the furniture tables window. This thing is still running. So I just wanted to see the work that this thing is putting together. Right. So this value will be calculated. This value for furniture tables, which is this 757,000, it will be computed and reported for all the 861 rows in that window. So I've just isolated one window, the furniture tables window. Remember, we are partitioning by category and subcategory, and this is just one of the outcome. Let me go back to this if it's not showing. It's still processing. If you look at the query, our partition is by category, subcategory. So it goes into the window and then sum the sales while respecting the categories. So if you're looking at furniture on category, this is exactly what I'm explaining right here. Now it's loaded. So this right here, I want you to see that there are 861 rows for what? Furniture tables window. If you go to this query, I will have to zoom into this. This is tables, furniture tables window. I will have to go all the way to 860 something to see the end. You see, it's still furniture tables, furniture tables. You have to go all the way down to 860 something. Let me take that specific number, 861. I really want you to understand how windows are built, especially when you start using multiple columns to partition. So let's go all the way to 861. From 862, you see something different, a different combination. So as long as you're within 861, you're looking at furniture. Oops, I think I missed something right here. So furniture tables is so we are still in furniture tables. I'm going all the way to furniture tables, and our target is what? 861. Furniture tables, combination furniture tables, and furniture tables right here. This is 700. Let me see if there's any other. I'm going to take out this and run. The furniture table is supposed to go all the way to 861. I want to see where this ends. Furniture tables ends right here at 792. So this is the furniture tables window. The next one is office supply. But why is there a difference in this? So when I zoom into just furniture and tables, I am getting 861 rows. Okay, let me compare them on the same platform. I'm going to take this and this. Since we are summing, and I'm going to add this thing right here. I think that the other one is giving more because of that. I'm going to add this thing right here, take out this, and let's run this. Let's see. Distinct combinations of furniture and tables. Yes, we are back to 781. Yes, 781. That should be the magic number, 781. So if we go now to the window environment, the furniture tables window should have 781 rows. So the issue was a distinct, right? So if I run this and I zoom into the furniture and tables window, it should go all the way to 781 before we can see the next window, 781. She can go slow, 781. Right here. actually 790. This is still different. 791 furniture tables, 791. So that's how a window is defined. But I don't understand why the numbers are not matching. Furniture tables window should go all the way to 791. So this one has
Maybe you have,
700.
maybe you have to use the distinct as well. Or
Yeah, maybe I need to add this thing on that. But I hope you guys understand what I'm trying to do right here. So if I put this thing on this and I zoom into furniture and tables, I get 781. So something, if I do it on a window environment and I zoom into the window for furniture and tables, I'm getting 792. Right. Okay, let's throw in a distinct right here so that we have the same logic on both sides. Run this. Okay, now let's zoom into that's distorted. Okay, that's distorted. So we're looking at furniture and tables. Furniture and tables. I'm even just stressing myself right here. You know what? I can actually bring in the row number so that we can see what we have in each window. All right, so I can just add a row number. I can do it right here, right? It doesn't matter the position. So let me show you what I want to do. I want to add a row number, and the goal is to rank the rows based on category and subcategory. Right. Because it's going to mimic the structure you have for the partition. So this is a row number, right? And all I need to do is make it in a window environment over, right? And I'm going to use the same logic right here, partition by this and this. This is not enough. This will give an error, right? Because the row number function needs an over clause to do its job, right? So let's rank based on sales. So I'm just going to go right here and do an order by sales. Now if I execute this, so we're back to furniture tables. I just need to go now I'm going to be using this numbering right. I just need to go all the way to the last combination for furniture and tables and see that number. The last combination for table and furniture. So right here, 850. Now this is giving us 850. See that from 850, we go into a different window and it resets. Now we're looking at furniture, bookcases, it goes back to 1. Right, I want to make sense of why 850 and then on this side, furniture and tables is giving us 781. So most likely, let me dismiss the distinct and run this. 861. Back to this, what do we have here? 850. We're still missing a couple of stuff. Right, but I was just trying to show you how the windows are built since we extended it into multiple columns for the partition bar. So each distinct combination of this and this constitutes a window. And you can clearly see from this at the end of each window. So as long as these two are the same, as long as this and this This is furniture, this is tables, that constitutes a window. And you're going to see the same throughout. And the numbering, since we're doing the ranking based on sales, at the end of that phase, once we change to a different subcategory, then we have a reset on that function right here. So now we're into furniture, still furniture, but now a different subcategory, furnishings. So basically we are in this. So furniture, furnishings right here. This is 385 something, and we see that same number. So that same number on the total sales is going to be reported throughout. So furniture, furnishings combination starts here at 1. That's the window. It extends all the way to what? See, a lot still showing up all the way to this. So for furniture, furnishings combination, we're getting 156 rows in that window. Let me try it on this side. Right. Furniture, furnishings combination, how many rows do we get? I think the reason is we have to be showing the distinct outcomes. And just putting like that, it's going to inflate. Not still helping. Furniture, furnishings. Just a moment, let me see if there's any other. Yeah, this thing is, it's another segment right here. All right. So it has two different segments, furniture, furnishings, and then it comes back to furniture, furnishings. Another segment, furniture, furnishings. So all of them are not put in one group actually. I've seen a segment above furniture, furnishings. There's another one right here. Let me see if I can actually, and I'm not making use of any other one. So if you're having that kind of behavior, you can just throw in an order by and this. Let's see if this is going to help. Let's run this. Furniture bookcase. Okay, by adding an extra order by, I'm controlling the output, the final output. This is also going to help to reinforce the window sorting. All right, so if I run this, now let's check furniture bookcases. I'm going to check furniture against bookcases. The second order by will help to reinforce that. Furniture bookcases, we are looking at 1,760. Furniture bookcases. If I go back right here, furniture bookcases, I'm now relying on this extra order by to keep the windows together. Right. Furniture bookcases. This is going to be a large group, furniture bookcases. Okay, you're still in furniture bookcases. Furniture bookcases. I want to go all the way to the last row in this window. And then we check the number. So this is the same window. As long as you're seeing this and this combination is the same window. This is the furniture bookcases window. So one key thing to watch out for window functions, you get to see the detail rows that are participating in each window. In a group by, you don't see the detail rows participating in a group. Right, this is a very important difference. So this is the end of the furniture bookcases window, and we're getting 2,411. This side, how many did we get? We had 1,700 something. So it all depends on how we're playing with the distinct, use of distinct and use of non-distinct. So something is going on this. So in the equation I wanted to solve was a scenario where we're sorting by the total sales. We do the ranking based on the combination that has the highest total sales. And I'm going to put order by that descending. Right. So within each category and subcategory, that's our window. This is how the window is defined, and this is the same structure we have right here. Let's rank based on the subcategory with the highest total sales, and we are doing that within each category. So if I run this, it's an error. Column, this category is invalid in the select list because, oops, I think I put that in the wrong spot. Column, this category is invalid in the select list because it is not contained in aggregate. Oh yeah, if I'm using an aggregate function right here, it will want me to put this and this in a group by. That's going to take me to a different kind of analysis. That's not what I want to do. I'm going to dismiss this and just go back to ordering on the sales, not on the total sales. Right. So in this, we have this particular one has the highest total sales, followed by this, right? And I can just add the order ID into this. So this will help now to show just those. This could be an equation, can be asked to extract the two orders with the highest total sales for each combination of category and subcategory. You first of all have to rank them. Let me just add an order ID so that we, right, and just to make sure we are looking at two different orders based on the order IDs. This ID is different from this. These are two different orders, right? So it is looking at all orders that came in for furniture and bookcases, and we are ranking them. These are the top two with the highest total sales. And once you're done with that, it goes to another combination. This is furniture and chairs. It's always difficult to spot that transition. Let me slow down right here so we can get the transition. I'm going to show you in the next question, in the next lecture, how to extract those. This is now the top two orders with the highest sales for the furniture and chairs window right here. And if you zoom to another window, you're going to see that now this is furniture and furnishings. There's a transition I have to slow down right here. So the function resets, you see the ranking, these are the two orders that came in with the highest total sales for the furniture and the furnishings. Right. This is what you have to do. In this, you will not be able to achieve that. This is group by. It doesn't explore these full details as we're seeing right here. In this case, we are examining the individual orders that came in. You see, I'm flagging the order ID. When an order is placed by customer, an order ID is automatically generated to identify the order. So in this analysis, I am showing you all orders based on a particular window structure, based on category and subcategory. So all orders that came in the furniture and chairs category, this is what we are seeing right here. And then we've ranked them. This is right here is furniture and furnishing. We've ranked them. And the next analysis it could tell you to show the two orders with the highest sales for each combination of category and subcategory. You will not be able to solve this kind of question with the group by. The group by will just give you this. It makes the work easy. It goes furniture, chairs combination as a group. It sums up all the orders that came in for furniture, chairs combination. The job is done for that. This is just summation. On this one, what is this? This is a group for furniture and bookcases. This is a summation of all the orders that came in for furniture and bookcases. In this analysis, you don't get to see the individual orders. I can throw in the order by the individual orders. Why? Because we are looking at this exercise from a window perspective. And each window is defined by the category and subcategory combination. Right. This is very important. And let me go back to this. Let's throw more light on partition by. You can see right here. Let me go back to this department, this salary stuff. We are sorting the salaries based on each department. If I execute this, I can give you a follow-up question. Give me the top 2 employees with the highest salary in each department. Top 2 employees with the highest salary in each department. In the accounting, this will be these 2 guys. Right. All you need to do is just add a where clause. Whenever the row number is 1 or 2, we are extracting it. See that? That's the condition you're going to add. In the finance department, there were 6 employees. The top 2 employees in this is this and this. And you discover that top 2 will only be possible if you point row number in 1, 2. Each time the row number is 1 or 2, you're looking at the top 2 employees in each department. You've already partitioned by department. And the row number function is resetting itself per department. So you're going to see this kind of questions a lot. It's the same question in that Uber transaction. We take all the Uber rides done by a particular user, we put them in one group, partitioned by user ID, and then we sort the transactions based on the order date. And then we use a row number function to go into that window and rank them. First transaction, second transaction, third transaction, fourth, fifth, and so on. And then the business wants you to just show the third transaction of each Uber user. I can also ask you to show only the employees with the highest salary in each department. In that case, I'm zooming only on this for accounting. I'm zooming only on this for administration. I'm zooming only on this for executive. I'm zooming only on this for finance. If you notice the trend, something is common. I'm just highlighting only cases where the row number is equal to 1. So whenever the row number is equal to 1, you're looking at the employee with the highest salary in that department. So you first of all project everyone, rank them per department, and then you go isolate only cases where that ranking is equal to 1. That's how you solve that kind of question, right? That particular one can be solved even with a group by, but when you start looking at the first 2 employees in each department, you will not be able to achieve that with a group by. Right, so visit each department, show me the first 2 employees with the highest salary. right? You have to do some ranking, right? So that is a row number function. The key thing to remember for row number function is that it generates unique sequential numbers for each row in the window. And the fact that it has unique in the definition, it means that if two or more rows have the same value you're testing, that's a tie, they get different numbers for the row number function. That's very important, right? Now I can take you to the next ranking function, which is a rank function, this one. This ranking function differs with the row number function. They disagree as to how ties should be treated. This is a very important difference, right? So whenever we switch now from row number to, it's going to be the same exercise, same thing. We're just going to dismiss this and put rank, right? So in the rank, it's slightly different from row number. So what's the difference? If two or more records are identical, the rank function will give them the same rank. It's now bringing logic. If you and I have the same salary and we are ranking based on salary, you should have the same rank. That's logical. So the rank function brings logic into this issue. The only difference between the rank and the row number is on the treatment of ties. As long as ties are not encountered, they will behave the same. But if ties are encountered, the rank function says, hey, these two have the same rank, they have the same salary, let's give them the same rank. And then there is a price to pay. It skips the next rank. I will have to show you this in an example. So if two or more employees have the same salary, they get the same rank, and then the next rank will be skipped. So when it comes to the rank function, there's skipping of the next rank after the ties are assigned. This is very important. And that skipping behavior is what is discouraged when you go to the dense rank function. So this one comes in to solve a problem caused by this, and then creates its own problem. This one comes in to solve that problem, you see. So the only difference between rank and dense rank is the treatment of ties. So the rank function will assign ties the same rank, and then it will skip the next rank. I have to show you that. So it's the same query we've done above. Only thing that has changed is this. I'm changing from row number to rank. And remember, all these ranking functions, they take nothing in the parentheses. No parameter is passed into this function. This is always going to be empty. Row number, rank, dense rank, always going to be empty. They always need the over clause. If you want, you can test that. Let's dismiss this. Call this and dismiss the over clause. All of them need the over clause because they are window functions. All window functions use the over clause. You get an error, the rank must have an over clause. See? So that's how you study. Dismiss some of these things and then provide the over clause and then dismiss the other by in the over clause. We've provided the over clause. It's a rank function, it needs the over clause. Additional requirement for these ranking functions, all of them, they need the order by. The order by defines the structure so that the numbers can now be assigned based on that structure you've defined. So in this case, what's the structure? We are sorting by salary descending. No partition by, so all the rows are part of the same window. Now we can execute this. Take note, this is a ranking of employees based on salary. The employee with the highest salary has in the entire business. We are not partitioning by department, you see. This is this guy, the highest salary, rank 1. If you go to the second position, these two individuals have the same salary. You see what the rank function did? It gave them the same tie, the same rank. This is very, very important. If you go back to the row number function, we had different row numbers. This was 1, this was 2, this was 3. This is very important. And usually, to make students understand this, you can just stay on that same stuff and print out another copy of that same stuff and then switch it to a row number. I'm going to preserve this as a rank. I will switch this to what? Row number. That's the best way to study this. So you see the behavior up front, right there in front of you. See how they're behaving. So this is row number. It's the same sorting. Let's call this row number. That will differentiate. And that's how interview questions, all right, so you can actually see this and know how to strategize on answering that. See, as long as there's no tie, this is outrightly the person with the highest salary in the company, no competition. The roll number function and the rank function are behaving the same, no ties. You have to see this and understand it, so that when you say in an interview, you're saying what you know, what you've seen, what you've experienced. Right, this is it right here. In the absence of a tie, the rank and the roll number functions behave the same. They all agree that this person has a higher salary, roll number 1, rank 1, same behavior. When they go to the second, you have to understand that roll number is what? Unique sequential numbers. That word unique is very important. These two persons have the same salary. Roll number says, hey, we're going to give them different ranks. My goal is to assign unique sequential numbers. So no two persons will have the same roll number. It's never going to happen, you see, even if they have the same salary. All right. Now, what does rank say? No, it is logical. These two have the same salary, and we are ranking based on salary. They have the same. Let's give them the same rank. That's the difference right there. When ties are present in your data set, the ranking and the roll number functions will behave differently. And then that's a skipping of the next rank. We're supposed to go from 2 to 3. It skips to 4. This is very important. This is position 1, position 2, position 3, and then it goes back to position 4. So the 2 and 3 were occupied. So it continues from a positional perspective. This is a logical agreement that they have the same rank, same ties, same salary, same rank. But then it continues to a positional perspective. So this is position 1, position 2, position 3. This is position 4. It goes back now to position 4 and continues. That's why we see in the notes that in the rank function, there's what? Skipping of ties. Skipping of the next rank after the ties have been assigned. This is a very important thing to mention in an interview. Right. Let me go back to that website. Sorry, not the website. This is now ranking. Assigns same rank numbers when values are same. Rank function skips next consecutive rank number. This is very important. And just to take you ahead of time, the dense rank will behave the same as the rank. They all agree that the same ranks for ties agree on that. Where did they disagree? The dense rank does not skip. The rank will skip. And these are small details that they want to see in an interview. They want to hear from you. Right? You have to practice this over and over and over. Right? That's a key difference. These three functions, when it comes to ranking, roll number, rank, dense rank, they don't really bother about this last two. Right? They differ. Their behaviors will change in the presence of ties. This is sequential unique roll numbers. If you have the same salary, we don't care. We give you different roll numbers. Now, this person brings logic into the game. If these two agree on that logic, if two employees have the same salary, let's give them the same rank. But then the rank function says, I'm going to skip the next rank, right? Why am I skipping the next rank? Because from my perspective, this was supposed to be position 1, position 2, position 3. This is position 4. So when we assign 2 on the same rank, let's skip and go back to the positional aspect. You see, it now ties with the row number. It now aligns back with the row number. See that this is where the difference comes. Look at every salary where there was a tie. There's a tie right here. These 3 persons have the same salary. Go to the ranking. You see, they all rank 7. Go to the row number to get 7, 8, and 9. And there's a skip. See, you skip and go to 10. To understand the number following the skipping, you have to go all the way to the beginning and count and do the counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10. Yeah, students always get confused after skipping what next. So you can always go from the positional perspective and track down the position, unique positions. You understand why this is now 10. Let me show you another tie right here. All of these employees have the same salary. That's a tie. The ranking is given same 16 position on the ranking scale. Of course, row number, you have to understand that it will always be different. 16, 17, 18, 19. See that? After skipping, 4 are tied on the same position. We have to skip. To understand why this is 20, again, you have to go back and look at the positional, kind of the build up, and you discover this is position 20. Right? So that idea of skipping an interview, you have to mention that for the rank function. Right? And then we can, address the dense rank. At the end of the day, I'm going to put all of them in the same query so you can just see the difference. All right. In the dense rank agrees with the rank function. It's identical to the rank function. The only difference is that after it has assigned the same rank for ties, it does not do any skipping of the next rank. Skipping of rank is done only by the rank function. The dense rank does not support that idea. Why should we skip? We continue. See, let me show you an example. I've just switched the query to dense rank, and now we are testing that concept. Run this. Is there any partition by? No, no partition by. Let's go back to those ties. These two have the same salary. See what the dense rank function is doing. Same rank, 2, 2. Position 1, there was no dispute on position 1. This is outrightly the highest salary. See, the issue is how they treat ties. This is a tie right here. Dense rank says give them the same ranking. Instead of going to 4 like what the rank function did, it continued its job. These two occupy the second position. This is the third position. This is the fourth. Keeps going. No skipping of any rank after ties. And that's a very interesting thing to remember about the dense rank function. Let me take you to all the ties and let's look at them again. These are ties. These 3 employees have the same salary. The dense rank function gives them the same ranking. And then it continues business as usual. No skipping of the next rank. This is position 10, rank 10. We go to next 11 and we keep going. No skipping of the ranks. Now, to understand this and appreciate this, you have to go to a query that lists out all of them in one. This is row number, this is rank, this is dense rank. You have to project this and then you can understand the behavior. Let's look at salary. Of course, this person has the highest salary in the business. No question, no dispute, no conflict. You see, all the functions agree that, hey, this person should get row number 1. There's an agreement. This is one thing to realize. All these functions approve the same behavior in the absence of ties. Only thing that sparks a difference is ties. Immediately we get to ties. Second position, you can dispute the second position. Should we give it to Nina or should we give it to Lex? They have the same salary, identical salary. The row number is not into that. We are giving unique sequential row numbers. So this is 2, this is 3. I don't know what criteria they use to list Nina first and Lex second. Right? You can control this behavior by adding another column to the order by. Now you can that's what we call a tiebreaker. Right? So you can actually go to the function right here. It's not going to impact this anyways. You can just put a comma right here and add another column on the order by. That's going to play the role of a tiebreaker. See? Right. But then let's continue on that. I really want you guys to understand this. And like I said, it's a popular interview question. Right. So the ties, yes, row number is doing its job. Unique sequential numbers. This is 2, this is 3. You'll never see a row number function and you see identical values on the row number function. It's never going to happen. Right. So salary, rank function on salary, the ranking, these two have the same salary, they get the same rank, 2, 2. the dense rank also agrees to see with the difference. Why the rank is skipping the next rank after the ties have been assigned, the dense rank continues business as usual. That's a very important difference right there. Like, I really want you guys to sit back and work on these examples so as to understand. Like, if I take you back to, see, this gentleman mentioned this in one of the posts. Right here, this one. Popular interview question: what's the difference between rank and dense rank? You have to understand that rank and dense rank agree on the treatment of ties. If two individuals have the same salary, they all agree that they should have the same rank. Right? But where is the difference? Rank will skip the next rank after the ties have been assigned. Dense rank disagree. We're not going to skip the next rank. We're going to continue the ranking process. No skipping. So SQL interviews for data analysts and data science jobs love to test you on window functions, and one of the most popular window functions that shows up is the rank versus the dense rank. So knowing this is critical, it's crucial. See, this is very important. Essentially, rank is to select what, dense rank is to select this thing. That's another way to look at it. Let me read this again. So rank is to select what, dense rank is to select this thing. Right. Always remember that the dense rank, no skipping of the ties. So rank gives you the ranking within your ordered partition. Ties have the same rank. Same thing with the dense rank. Ties will have the same rank. With the next ranking skip, this is the skipping behavior is for the rank function, not for the dense rank. This is very important. So if you have 4 items at rank 2, the next rank listed will be rank 6. Let me demonstrate this. Let me just put snipping tool. I want to zoom into this part and cut it off. What's that part? This part that says, if you have this part, I need to cut this part off. Oh, no, just gonna cut everything. It's a new. This part right here, and I'm gonna demonstrate it on this side. Or I can actually stay right here and just demonstrate that. Let's get a pen. It's a pen. Let's demonstrate this. So if you have 4 items at rank 2, so we have 1, no dispute. When we get to 2, we have 4 items. 4 employees have the same rank at position 2. This is what 1, 2, 3, 4. So first, no dispute. I want you to focus on this. So if you have 4 items at rank 2, this is rank 1, no dispute, 1 item right there. Rank 2, 4 individuals are tied in rank 2. For the rank function, this will give you 2, 2, 2 for the 4 items that are tied. And then the next will be what? Can somebody tell me what the next will be on the ranking for a rank function? I'm going to do for rank function, and then I'm going to show you what the dense rank will look like. This is a rank function. So your ranking items, the first, no dispute, no ties, rank 1. Position 2, we have 1, 2, 3, 4 individuals are tied in position 2. After assigning the ties to this, what will be the next rank for the rank function? You have to go back and count 1, 2, 3, 4, 5. This will assign 6. And that's exactly what he's saying right here. If you have 4 items at rank 2, the next rank listed will be rank 6. This is a ranking program. That's the rank function. 1, no ties. On the second position, we have 1, 2, 3, 4 are tied. They all have the same ranking, second position. The next rank will be skipped. We're going to go to 6. And This always confuses students, and an easy way, always go back to the beginning and look at the position. Position 1, position 2, position 3, position 4, position 5. This will be 6. Now, let's do the same thing for a dense rank function. Dense rank function. I really want you all to understand this. In the dense rank function, of course, there will be no dispute. This is going to be rank 1. Now, all the 4 items that are tied on the second position, they will be listed. This is 2, this is 2, this is 2. 4 items are tied in the second position. Can somebody tell us what the dense rank function will return for the next rank?
Let's say 1 to 2.
Yeah, this is usually a little bit
Would it be
tricky.
6?
No. 6 will be for the rank function because skipping of ties. What will this return? Dense rank, no skipping of ties. It's business as usual. After 2, what is it? In the position after 2, what is it? 3, right? This is 3. This is very important, guys. Yeah, this is a trick stuff. And usually, there are some very smart people in the interview panel. Once they know that candidates are very good at definition, they've memorized things, they can challenge you from a practical perspective. They give you a scenario to test your knowledge. And that's where most students go and candidates fail in an interview. It's always easy. You ask anybody, they'll tell you this, rank will do this, dense will do this. Give them a scenario and challenge them what will be the outcome. And that's where the read test is performed. You see, this is very important. So if you have 4 items at rank 2, rank 1, no dispute, this is 1, rank 1. Rank 2, we have 4 items. That's 4 individuals with the same salary. They all occupy the same position. This, and this. 4. Right? All of them in rank 2. What will the rank function return after the ties? You have to understand that the rank function does skipping of the next rank after ties. And it's always very confusing. Go back to the beginning and look at the position. Position 1, position 2, position 3, position 4, position 5. The rank function returns 6 in this position. And you see it has skipped 3, it has skipped 4, it has skipped 5, it has gone to 6. That's what it says, skipping of the next rank after the ties have been assigned. Dense rank function does not skip any ties. It agrees with the rank function that, hey, these 4 individuals have the same salary. Let's rank them all in position 2. But then the rank function continues business as usual. This is all rank 3. The next one is rank 4. No skipping of ranks. Are we okay? This is very, very important. Let me see if I can take you guys to Google and let's find out if oops, I want to go back to non-drawing mode. Yes, let me take you back to Google. That's my stuff. Okay, let's do rank versus dense rank SQL. I always want to attach SQL to it so that the system rank versus dense rank SQL. And usually just go to images. Let's see what images we have. And this right here. Can we all see this? This again is salary. So John has the highest salary in the company. Row number, rank, and dense rank all agree that is 1. Highest salary in the company, the ranking is 1. When we get to the second position, Mark comes in. Mark's salary, there's no dispute. Mark has the highest second salary in the company. They all agree 2, 2, 2. Row number will return 2. If you are using the rank for ranking, it's going to return 2. So where is the conflict? Let me see. So basically, there's no dispute on this. It's no dispute. This one is straightforward. There's no dispute. You see, and this goes back to reinforce the narrative. In the absence of ties, all these functions will behave the same. They all agree in the ranking. There's no different ranking. See, they all agree. Yeah, this is one scenario. Please remember this. In the absence of ties, the row number, rank, and dense rank functions will behave the same. Let me go look for a scenario where there's some, for example, this one. Let's check out this one. If there's any difference in behavior. Have you guys spot any difference in behavior? Yes, right here. In this scenario, Mark and John have the same salary. This is the original table, and this is the ranking that we are doing. Mark and John have the same salary, 8,000. See, rank and dense rank, they agree that Mark and John should be ranked the same. The rank function gives 1 to Mark, 1 to John. The dense rank function gives 1 to Mark, 1 to John. They are ties. Let's rank them the same. That's the agreement. What is the next thing the rank function does after ties are assigned the same rank? Skipping of the next rank. We're supposed to go to 2. This position 1 is doubled. This is supposed to be position 2. But then the dense, see what the rank did? It skipped to 3. And how do we get 3 right here? You have to look at the positional part. Position 1, position 2, position 3. For Tom, the dense rank says, no, we're not going to skip. We're going to continue as business as usual. We go to 2. Position 1 is occupied by 2 individuals. Position 2, we go to position 2. See? This is very important. This is a clear indication. And sometimes they can just give you this and they tell you to go to the board and build the outcome for rank and dense rank columns. Whatever you've said in the literature, in the interview, that's fine. They cannot challenge you practically. Just prepare a piece of paper like this and just put rank right here, put dense rank. They keep blank on all of this. They tell you to fill the spot. You have to start learning how to challenge yourself in it. Right. There's a difference between somebody who just reads and somebody who works on projects and see these things happen. It is very, very important. There are people who can define inner joins. They just give them 2 tables and go ahead and do me an inner join. Let me see what you can do. They won't be able to. So practice is very important. You see that? Right. So this is very, very important. You should go through this and make sure you understand the behavior. Right. And that's how you can reinforce this. Right. Very, very important. Is there any other tie in this? I think the only tie was this first position. This is all different, all different. Right? So you see that offset right here. It pushed this to get to 3, 4. Why this is a 2, this is a 3. See that offset. Right. If you use the row number function, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See? So the row number function will disagree from this part right here. This will be 1, this will be 2 for the row number function. Right. So that one is always easy. It's like the base. Students will always remember that one. Let's see another example. I like this one. It has the row number, the rank, and the dense rank. Let's check out this. It's the amount. Maybe an amount. You're checking out these names across this amount. First position, the amounts are tied. Row number is not into that tie stuff. We're gonna treat it as different. Unique sequential row numbers. 1, 2. Rank and dense rank will agree since they have the same amount. 1, 1, 1, 1. Row number keeps it simple. We go into the third position. You don't, no confusion, no advanced concept right here. Go into the third position. Rank, right, skipping of the next rank after the ties. This is 1, 2, 3. Position 1, position 2, position 3. So anytime you get confused on what the next rank will be after the ties for a ranking function, go back to the first position 1, position 2, and then this is position 3. The dense rank, no skipping of ties after the ranks have been assigned. That's why we go back to 2. First position is tied by 2 individuals. They all have 1. We go to 2. Next position 2. Next ranking is 2. I think that's the only. There's another tie right here. 400, 400. No, 4,000, 4,000. You see, roll number is the easiest. Just keep doing our stuff. Unique numbers for each row. We don't care if it's a tie or not. They all agree again. 4 on this side, 4 on this side. Remember that in this side we are on 2, so this will be 3, this will be 3. This you have to sit back and study this and understand. And then how do we get to 6 on this? For the ranking, you have to go positional wise 1, 2, 3, 4, 5, 6. After the ties have been assigned, there's no skipping of the next tie. We go to the next available number, which is 4. Rank 4. Have 3, 3. This is 4. This is very important. I really want you guys to create time and go over these concepts like this. Look at this one again. First of all, always spot what they're trying to look at. It looks like they are ranking based on what is it? What? Okay, it's based on the order date. Is it order date? Yes, order date. I'm sure about that order date. If you doubt, just go to where the ranks, the ties are allocated here. These two dates are the same dates. Yes, so it's ranking based on the order date. So these two orders came on the same date. So the ranks are what? 7, 7 for the rank function. Dense rank 7, 7. There's a part of this that has been. Don't ask me how we just got to 7 immediately. So they're not showing the full picture, right? So for the row number, this is 7, this is 8. See, there's no confusion. We don't care if this is the same date. Now, rank, we skip the next. This is 7, this is supposed to be 8. If this is 7, this is supposed to be 8, and then this will be 9. See that? So the skipping of the next round, that's 8 has been skipped. You're now at 9. Dense rank says no skipping. This is 7, 7. We continue. This is 8. See that? The next tie occurs on this date. December 27, December 27. There, you see 11, 12. No tie stuff on the row number. We can always ignore the row number. It's going to behave just the way you want it to behave. The confusion is always going to be on the rank and the dense rank. Right. So this is 11, 11. We agree. They are tied in that position. Dense rank also agrees, but then it is in continuation of the previous. This is 9, so the ties will be given 10, 10 for this side. See, very important. And again, that skipping behavior ushers in. This is 11. This is opposed. This is 9. This is 10. This is 11. This is 12. This will be 13. Skipping of the next rank. 12 has been skipped. This is 13. We continue business as usual. 10, 10. This is 11. We go to 12. See. Again on 12, this is tied. This is January 7, 14, 14. You see, practice this. Right, this is just as easy. Go to Google, type in that search, go to images, have something like that, and just challenge yourself to make sure you understand how this is built. This is very important. This is another scenario right here. And the person even added some annotations. So salary, I'm guessing we are sorting based on salary. So the window function will have an order by salary descending. Ronnie has the highest salary, no dispute on that. Rank and that they all agreed as one. We go to the next one. Yes, no dispute on the next one. We go to this, no dispute. We start having a dispute on this one. This, and this. 3 ties. Ranking 4, 4, 4. Dense rank 4, 4, 4. No skipping of the next round. We go to 5. Ranking, there's a skipping of the next round. This is 4, this is 5, this is 6. We skip to 7. So skip numbers 5 and 6 and we go to 7. no skip in the dense rank function. Right, this is very important. So you saw what I did. Just go to Google, type rank versus dense rank. Make sure you put SQL so it understands the language you're searching. Search that, and you can always switch to just the images. It helps to study something vividly from a visual perspective. Right. Okay, we're going to end here for today. We're going to come back and work on this during the lab session on Wednesday. Okay, good night, everyone. Any question before we go? So hopefully you can now prepare, read, and then provide this explanation nicely and accurately in an interview if this shows up. They even had an example right here. Right. As somebody is protesting this interview question, it drives me crazy that an interviewer would care if you know the difference, as long as you know that these two exist and there are differences between them. You can Google the syntax to figure out which one is which. I agree with this. And that's the funny thing about these IT jobs. The most difficult part is the interview, because by the time you get that job offer, this will be your friend, Google. We don't stress into the job. You just Google anything, right? And now there's AI coming in, right? Chat GPT is around the corner. You have a lot of resources, right? And when you finish in this training, we're gonna put in the big group. We have every students who are created from the training, working on different companies, different projects. There's no project that's gonna be more than you, right? You have all the resources you need. You can reach out to me, Moke, anybody you want to reach out. Use Google, use Chat GPT. So whenever you're studying, guys, the challenge is that interview. That's your focus. Let me just grab enough information so that I can go to that interview and beat the interview, impress the interviewers, and then give me that job offer. That's all I need. You see that? That's exactly your one focus. Yeah, I will agree with this person. I don't even, but you understand that when they launch a job offer, so many people apply. So what criteria can you use to select the candidate? See, you guys are here putting in your effort to study. There are people who just go and fake stuff, write all sorts of fake things in their resume, and they're going to apply to the same job as you. Right. Meanwhile, you're building yourself. This is a 6 week of SQL. All your weekends have been taken up. You have another maybe 5 weeks of Power BI, and you've put in a lot of effort. Right. So you have to understand that the goal is to beat that interview. And there are some very crazy interview questions that people ask. But hey, that's just the setting. And I very much agree with this. See, a simple search on Google will tell you a difference. If you have a project, you can use that. But of course, companies don't want to babysit. They want you to come in with some information. You know something. They don't expect you to know everything, but know something, a solid foundation in the SQL language. Right? You can build a dashboard if you're given a project. There are some aspect of the dashboard that is going to give you headache. You can go to Google and find out stuff, find out some DAX calculations and stuff like that. That's research. All the IT jobs are research jobs, but don't show up empty. You see, that's the reason why you guys are attending this bootcamp, to get to know something about the SQL language, get to know something about Power BI. You can put that together and then show up in an interview and prove that, hey, I know something. Give me this job and I'll deliver. You give you the job, you provided computer from the laptop from the company, have several monitors. They give you everything you need. Just work and deliver. They don't restrict you on the where to go plug information. If you want to take your project and give it to somebody to do it for you, people do that. But then, of course, how do you grow? Growth is also a very important thing. See, so this is very important. This is to motivate and know when you're studying, you're missing out on a lot of things. I understand that your weekends are busy. You're building something. And people reach out to you once you succeed. People reach out to you and say, hey man, what's the secret? What classes did you attend? It's okay to sacrifice a couple of months of your life and get a good job than to, spend a very long time working funny jobs. See? So what you're doing right here, you're building. And of course, a company will hire you and pay you for all the time you've been studying. This is very important, right? So this is just to motivate you guys, right? The challenge is always to land that first job. You have to go through an interview and prove your worth. See, right? So this is to encourage and motivate, right? Okay, we're gonna end here for today. See you on Wednesday. Okay, good night, everyone.
Yeah. Thanks, Austin. Goodbye.
Yeah, man. Bye bye.